Hello and welcome to this new video on Python. This is meant to replace my earlier series on an introduction to Python by providing you with a complete overview, or not really a complete, but a fairly good and comprehensive overview of some of the main things that you need to know getting started with Python if you're an absolute beginner. Along with this video is a free textbook. Some of the stuff that I talk about in the video is explained in greater detail in the textbook, and some of the stuff that I explain in the textbook is explained in greater detail in the video. They're meant to work side by side. The link for the textbook is in the description down below, but it's python-textbook.pythonhumanities.com. It is a mouthful, so do look for the link in the description down below. As always, thank you to all of my Patreon supporters and people who have joined my YouTube channel. Your financial support helps keep this entire channel afloat. I put all these textbooks and video tutorials out for free for everyone, and your support does go a long way, so thank you. And if you get a lot out of this textbook, please do consider supporting the channel and joining it down below. So what I'm going to be covering in this textbook is kind of the starter stuff that you need to know to get started with Python. It's designed for absolute beginners, people who might not have any coding knowledge whatsoever. It's designed for humanists like myself, people who might be historians or English majors in college. It's designed for you all, and because it's designed for humanists, it's designed for those who are learning to program who might not be computer scientists or data scientists or necessarily wanting to do any of that. It's designed specifically for those who are genuinely curious about Python and how it can be applied and leveraged to their own discipline. So about myself, this is all covered in Chapter 1 of the textbook. My name is Dr. William Mattingly. I have my PhD in medieval history from the University of Kentucky, and I right now work as a postdoctoral fellow at the Smithsonian. This textbook is, like I said, just meant to be a general overview for it. It's all based in Jupyter Book, so if you see a problem, you can report an issue using one of these buttons up here and this little handy GitHub icon. So you can open an issue, open it up in the repository in GitHub, which you're probably not familiar with if you're just starting out, or you can suggest an edit to fix maybe a typo. Because this book has not been, peer reviewed, there are going to be some typographical or even maybe some actual context errors within it. I've tried to clean them all up as best I can, but because this textbook is community inspired, I would like for it to be kind of community driven. And I go through in Chapter 1 of this textbook and kind of work you through why you might want to consider learning Python. And the answer really comes down to the ability to automate or pass tasks that are either boring, repetitive, or too cumbersome for a human off to a machine. When you learn to code, you learn to do things in a computer system, which means that you'll be able to robustly accomplish tasks that would otherwise be impossible to do as a human. You'll be able to parse 300,000 text files if you want to in a matter of just a few minutes. You'll be able to manipulate data, change it, alter it, restructure it the way that you need to. You'll be able to work with data or text or numbers or anything that you want. We're going to explain all of that in this textbook. You'll be able to work with it a lot more powerfully and a lot more quickly. But one of the caveats comes is that when you start working with data in a large quantity, there is a chance that your methods will not be 100% accurate. And you have to kind of accept that and work as best as you can to remove all of the errors or mistakes that you can in your Python script as you're working with data. That's more advanced. This textbook is really kind of geared towards beginners who are just trying to work with data at a very basic level. In the future, there's going to be a follow-up to this textbook where we explore these concepts in much more depth, but essentially this is meant to function as a primer so that you can go to the YouTube channel on which this sits and start working with other playlists that are going to do deep dives into things like natural language processing, network analysis, data frames such as working with pandas, and everything else that you can find on this channel if you go to the actual page. So this textbook is, like I said, meant to function just as a primer to kind of go through and do that. But real quickly, before we jump in, you should know a bit about the language that you're about to learn. So what is Python? Well, Python is a programming language, and what programming languages allow for you to do is write something in a fairly close facsimile or representation of English in a script that will then go to what we call a compiler. Again, this is explained in detail in the textbook if you want to read about it. And then that compiler will translate what you need to do into some machine parsable data. So converting it into binary so that it can effectively load what you want to do into memory and then pass it off to your processor to actually do it. Again, I explain all this in detail. So all programming languages really kind of function on this basic principle. Some will do it a little bit differently. Again, I detail all this in the textbook, but really, if you ever hear somebody say that one programming language is the best, they're speaking from a place of ignorance. All programming languages have their strengths, and really it comes down to using the right tool for the job at hand. So where does Python really fit into the overall hierarchy of programming languages? It's going to be one of your slower programming languages, but it's so widely used because it is easy to understand, it is easy to write, easy to read, because of something that's called forced indentation, which is different than other programming languages. We're going to learn about indentation as we get into things like loops and conditionals and the third part of this textbook. But it is as a programming language that allows for you to do everything. So you can really create apps in Python. I have a whole tutorial on Streamlit that allows you to easily create web applications. But it does things like that R or that is a statistical programming language just can't do. There's other programming languages out there like C that are very efficient and very quick to actually run, and it's the basis for really a lot of the software that you use. There's JavaScript, which is really good for doing web development. My point is, there are a lot of programming languages out there. Python is particularly good because of its ease of use, ability to write, the fact that there is a large, giant community out there that supports it, which means if you have a question about Python, you'll usually be able to find the answer by just Googling your question. And on top of that, there are a lot of libraries, which we're going to learn about in chapter 9 of this textbook. There are a lot of libraries out there that you can actually go to and use in your own script that are open source. So those are some of the reasons why you would want to kind of get into and use Python. Now, in just a few minutes, we're going to talk about kind of the installation methods for Python, but I want to emphasize that one of the most difficult things about using Python is really just learning how to install it. So one of the things that I've done with this textbook, as you're going to see in just a minute, is that I've kind of eliminated the problem of installation by creating what we're looking at here, which is a Jupyter book. A good way to think about a Jupyter book is as a textbook that allows you to engage directly with the code by opening up in Binder, which I'm going to talk about in just a few minutes. And this allows for me to also update the book. As maybe new things come out in Python, I can make an update to the textbook and it'll update automatically in the cloud. I cannot, however, update this video. So always do follow along with the video and the textbook, and always do kind of look to the textbook. If something's happening for you and there's an error, I'll make sure that I correct it in the textbook if you let me know in the comments, or somebody opens up an edit over here. But with that all said, that's going to be what we kind of do. We're going to go through and learn the basic concepts so that you can kind of get started right out of the gate over the course of the next 3 hours. I would encourage you to go chapter by chapter and follow along and try to execute the Python commands as I go through and teach them to you. From the very basic level of working with data to doing loops and conditionals, spend the next few hours with me, and I promise you'll leave this textbook with a good understanding about what Python is, how to do basic things in it, so that you can start doing more advanced things in your own field. Okay, now that we've already really kind of got a sense of chapter 1 of this textbook, which was introducing myself and kind of the book as a whole, let's go ahead and jump in to chapter 2, which is installing Python. Now, go through and look at this chapter on your own. I'm going to be walking you through kind of all these steps in this portion of the video. Now, the first thing that you need to understand about Python is that probably the most challenging thing that you are going to face is installing Python. And it's for that reason that I recommend for all new users to avoid this entirely by simply not installing Python. That might seem counterintuitive, but you'll find that all the frustrations that come with installing Python correctly on Windows, Mac, or Linux even, really can be avoided initially, and all that frustration, all that irritation about learning something new can go away entirely if you simply don't install it. Now, what do I mean by that? Well, What's nice about this textbook being a Jupyter book is that it comes with a handy dandy little feature. You might notice if you're looking at this screen right now or looking at your own notebook, that little rocket ship kind of in the top right corner. And you'll see it right here on your own window screen if you've opened up the Jupyter book. And what that is it's something called Binder. Now, if you click Launch Binder and you hold on Windows Control, or you right click and open it up in a new window, you will notice that you have a new window that looks like this. Now, this might look very, very scary. I'll zoom in a little bit so you can get a better look. But what we're actually looking at is something known as a special environment being set up remotely on a server somewhere else. This is the benefit of Binder. What it's doing is it's going through and installing Python on a server remotely that's going to have the same installation for all users regardless of operating system. It's also going to go through, and because I've set it up this way, automatically install all the different libraries that are going to be used throughout this textbook. And what you're going to be watching right now is essentially all this happening right here in real time. When this is done loading, you will have a new screen that is populated with the Jupyter textbook, essentially as a collection of Jupyter books. Why is this really a nice feature to have? Well, it means that once this is done, as it's wrapping up right now, you can actually engage with all of the code in the textbook on your own computer without even having to install Python. And what this means is that I can click up here, click File, New Notebook, Python 3, and I can just start following along from the very beginning. Now, what we're looking at here is something called a Jupyter Notebook. And if you don't want to use the Binder environment that I've got pre-designed for you, and you want to kind of do this on your own, I'm going to show you in just a few minutes how to create a Jupyter Notebook online for free without using Binder, without using my whole system that I've just displayed for you. But let me go ahead and explain real quickly what we're looking at. What we're looking at is something called a cell. Now, within this cell, I can type in some code. So I can type in, we're going to learn about strings in just a few minutes. I can create a string called str8, let's just say. And I can say my name is William. And then I can use Shift-Enter on a computer, on a Windows PC, or I can hit Run and execute that cell. And what we're able to now do is we'll see that we have a new cell populated. What I can do here is I can say print str8, and again, we're going to learn all about what print is in just a few minutes, but I can execute that cell and it prints off. It runs a Python command. What's nice about Jupyter Notebook is that it's designed for this exact thing. It is designed for instruction. And when we start working with the textbook, we'll be zoomed in a little bit more so you can kind of follow along a bit more easily. But for right now, just understand that what this is a cell that can be executed, and most importantly, it can store this data. Again, we're going to learn about data in just a few minutes. We can store that data in memory and allow us to execute cells. And what's nice about this is if you make a mistake, let's say I spell print wrong, an important Python command, I can view an error, and I don't have to worry about rerunning an entire Python script. I can simply go back up to that cell and re-execute it and print it off correctly. So it's a very forgiving environment or way in which you can interact with Python. So that's why I really recommend opening up this textbook as a Jupyter Notebook via Binder. And again, that's going to be this little icon up here. And it should only take maybe 5 minutes to populate and load up. Now, you might not really feel comfortable with doing that, or you might not want to do that, and that's okay. If you go down to the next part of this notebook, I show you how to kind of go through and work with Jupyter Notebook online, where you can just follow along with this video on one screen. If we copy and paste this link in, we'll be able to load up this page here at jupyter.org, where you can just try and experiment with either Jupyter Lab, which I'll talk about later, or Jupyter Notebook. If you click on Jupyter Notebook, you're going to see the exact same thing that we just looked at. It'll be a slightly different page, but if you create a new file, up here in File, New, and select Notebook, not Console, you'll be able to go ahead and follow along. Again, you just select Polite here. You'll be able to follow along just like we're able to do, but you won't be in the special Binder environment. What does this mean? Well, it means a little later in this textbook, when we start working with libraries, or things that you have to import from installations, you won't have those pre-installed for you. So later on in the textbook, this really won't work as nicely, but it'll work the exact same. I'm just going to say hello here, execute that cell, print off str8, and again, we're going to learn about what all this code is later on. This is just to show you that this will work just the same. Now, these are the two easiest methods for really following along with this textbook. Now, again, I encourage you to do this. Please, if you are not familiar with Python yet, or even if you're just trying to do a refresher and you need to reinstall it on your machine, please don't do that just yet. Follow along with this textbook, and only after you're kind of got the basics down, you feel comfortable, would I recommend going to step 2.5 here in this textbook, which is installing Python locally. Now, I kept these in succession of easiest to most difficult. You will eventually need to install Python locally. Again, don't do it now because it will be frustrating if you encounter some problems, which is very likely going to be the case. If, however, you do want to install Python locally, I'm encouraging all of my students to actually not install Python manually, especially on Windows. This can be kind of challenging sometimes because on Windows you have to do multiple extra steps that sometimes can confuse and maybe overwhelm new people to programming. And so for that reason, I recommend going to anaconda.com. And if we go to anaconda.com, you will be able to go through and find Anaconda Navigator. And what this is, if we click up on products and we go to individual edition, Anaconda Navigator is a nice and easy way to kind of go through and install Python. It handles a lot of the complications with installing Python, especially on Windows, and it handles them all for you just fine. If you're working on Linux, you can actually go through and install this for Linux. If you're working on Mac, you can install it there too. That's the nice thing about Anaconda Navigator, is that it will install very similarly across all platforms. If you're using Windows or Mac, go ahead and just click download and download the installer. And when that's done, go through the steps and install Anaconda Navigator. Once that is done, and again, the steps will just be going through and clicking next. Once that is done, this is going to flash a little bit, you will have Anaconda Navigator installed on your computer. Now, once that's the case, you can go ahead and open up Anaconda Navigator, and it will do a lot of things like this. It'll open up in Windows, your command prompt, and it'll go through and automatically load up something that's a little bit more complex and beyond the scope of this video, but it'll load up what we call an entire framework for working with environments. Now, environments are going to be in the second part of this video. That's going to be more for intermediate Python. It's really nothing that you need to concern yourself with when you're first starting out, but essentially what will happen after a few minutes, you will have the Anaconda Navigator nice graphical user interface pop up. Now, most of the time when you work with Anaconda Navigator, you're going to be working with it in the terminal. Now, as I noted in the beginning part of this video, I am not covering the terminal in this video because while Python is really useful for working in the terminal, again, this is something that can overwhelm a new audience or a new user to coding. And so for that reason, we're really going to be doing everything in Jupyter Notebooks. When you have a page like this, you'll have Python already installed in what's known as a base or a root environment. This is going to be the main place that all your main libraries will sit. Again, I'll talk about environments in another video on this channel, but for right now, just understand if you go to Home, you can install something called Jupyter Lab right here. You'll need to hit install. And once that's done, you can go ahead and hit launch. And what Anaconda Navigator is going to do for you, what you don't see happening on the back end, is it's going to load up a local host server for you. And you'll be able to follow along right through here, just like you can with every other notebook and the textbook. And it'll put you by default, I believe on Windows, it's in the user directory, so your username on Windows. On Linux, I think it's in Home. I could be wrong there. I'm not sure about Mac. But either way, you're going to have everything that you need here. And again, you can kind of see all my different folders that I have already loaded up over here. So again, that's going to be if you want to follow along locally. Again, I encourage you not to do that, and I encourage you instead to work with this textbook through Binder. So that's really the 3 different ways that you can install Python locally, at least as a beginner. When you get more advanced, you're going to want to install Anaconda a little differently and interact with it a little differently. And you're really going to want to control which versions of Python you have installed, which version of libraries. And again, all this is going to be done through something like Anaconda. So becoming familiar with it now is very, very useful. And I encourage you to kind of play around with it once you get past this video. So let's go ahead then and jump into chapter 3 of this textbook, which will be working with data. Now that we've gotten kind of that installation part of Python out of the way, it's time to jump in and start probably with what you're being here for, which is to start coding in Python, which for me is the most fun thing. When you first start out, when you first start learning about what data is, and you first start learning about how to kind of interact with it programmatically or through a programming language. So what we're going to be covering in this portion of the video, which is going to be really chapter 3 of the textbook, is again this introduction to data. We're going to be talking about what data is, and I think this is important because most people watching this video are not probably computer scientists, they're not data scientists, or maybe they have ambitions to be one, but at this point in your career, you don't necessarily know what data is. So we're going to start at the ground level and really work our way up. And we're going to do that by also talking about what types of data exist in Python. And we're going to be talking about really kind of a few things here. We're going to be talking about strings, 2 different kinds of numbers called integers and floats. If they sound scary right now, by the end of this chapter, you'll understand what they are and how they're different. Booleans, which is, again, what we're going to learn about in just a few minutes, a word that might not be familiar to you, but again, by the end of this chapter, you will know what a Boolean is. And we're going to learn a little bit about Python and how to interact with that data by manipulating some strings and learning a little bit about mathematical operations, which, at least if you've grown up in the United States, you probably haven't covered since maybe 4th or 5th grade of grade school, or maybe a little bit in high school. So let's go ahead and really kind of start off with some basic terminology. The first thing that I want to talk about is this concept of what an object is. Now, an object is something that you create in Python and that you store in your computer's memory. Now, a good way to think about memory in a computer system is to think about maybe your own brain, right? This is kind of where it gets its basis from. If you need to remember something, you store it in your brain. If you need to retrieve something, you retrieve it from wherever you've stored it. Memory in your computer works very similarly. It's stored on your computer, and this object is a piece of data that you are going to create in Python and then store within your computer's memory. The way in which we will call this object in Python is known as a variable. And these can oftentimes, if you're watching tutorials or if you are maybe looking at some help on Stack Overflow, which we're going to get to at the end of this textbook when we talk about kind of where to go from here, you're going to see a lot of people confuse these two, and they're going to oftentimes use them interchangeably. It's important to understand that there is a subtle difference here, and we're going to really kind of see that subtle difference throughout this chapter. So just think about the object as the thing that is stored in your computer's memory, some piece of data. It could be a sequence of text called a string. It could be a number like the number 1, but it's something that is a piece of data that is stored in your computer's memory temporarily. The variable is the name that we give an object in Python to call that from memory. So that's just an important little distinction here, and you can go back at any point. You can read about what this difference is in the textbook. So let's go ahead and jump over to just a Jupyter Notebook. I'm going to zoom in here for you. And what we're seeing here now is going to be some live coding. I believe the best way to learn about coding is through live coding. Now, throughout this video, I might make a couple mistakes. I might do them on purpose. I might do them on accident. If I do them on accident, I'm going to pretend and act like I did them on purpose. But no matter what, live coding is great because I will make mistakes and you will learn that mistakes are perfectly common and you should not feel embarrassed about them. There are 2 kinds of programmers out there. Those who don't seek help, and then those who are liars. So my point is everyone makes mistakes when they're coding, and everyone has to troubleshoot and debug. Otherwise, you wouldn't be here trying to learn. So this is what we're going to do. We're going to start off by just making an object in memory, and we're going to stick with what we just met a second ago. Let's call it str8. Don't worry about the actual code here. This is just to demonstrate a couple things right out of the gate. So I'm going to use an open and a close quotation mark here, and this is going to be what we call a string. We're going to meet a string in just a few minutes when we talk about text. I can say, hello, my name is William Mattingly. Wonderful. And then I'm going to go ahead and use Shift-Enter, or I could hit the play button, and that's going to execute that cell. Now at this point, I have taken this string, which is a piece of data, or really kind of just some kind of information that is going to be sitting in a computer memory, and it's now stored in my computer memory. str8 is a variable that I've also assigned to this string that is now stored in my Python script as a way to reference that object. So if I were to say print str8, I would be able to print off that string. And this is because I'm using the variable str8, which is in turn connecting up to this cell here, which in turn is looking at what I've gotten stored in memory, which is this sequence of text, this object in memory. And so that's essentially the backbone of really how to interact with all data in Python. What you're trying to do at the Python level is write something in fairly simple English, which is essentially going to be some kind of Python code, to then store something in your computer's memory. And then all you're really doing as a programmer is interacting with that data, changing that data, and manipulating it. That's a lot of what you're going to do at a very basic level. So what have I done here? Well, in this bit of cell 2 here, what we see is print, which is a Python command. It's a way you can execute a function in Python. And what you can see here is that I've got an open and a closed parentheses, which is again going to tell it to do something. And within those parentheses, I tell it what to do. Now the print function in Python prints off some kind of variable or some kind of text. So if I wanted to, I could say print off hello, and it'll print off hello. So what print allows for us to do is to print off text. This might seem very simple on the surface, and in a way it really is, but the print function, believe it or not, is going to become your best friend. It's how you debug your scripts or your Python programs that you're developing. It's how you just kind of like look at your data to get a sense of it really quickly. You will use the print function a lot more than you might realize. It's going to be your best friend, and I encourage you to pause the video right now. Try to create an object that is a string. So we're just going to meet strings in a second, but for right now, take a unique name, in this case str8. Do not use the name string. We'll talk about that why later. But just call something like str8, str1. Use the equal sign to create the object. Use an open and a close quotation mark. Again, we'll talk about why in a little bit. And then put some random text in here. And again, I've created a new object called str8, so I've effectively overwritten this variable in memory. And then I can print off str8, and then print that off. So again, pause the video and play with this. Try to recreate what I've just done here, and then pop back. And we're going to be going back into the textbook and talking about data more generally. Okay, so that's essentially the print function in a nutshell. One other thing that you need to be familiar with is this idea of case sensitivity. So what is case sensitivity? Well, let's imagine that I wanted to print off str8. And instead of using a lowercase str, I used an uppercase str. And I'm going to get this error. This is going to be a very common thing that you see, especially as you learn to program, and I still do this all the time. What this is it's a bug report, essentially. It is telling you in this reddish, pinkish colored backgrounded text that you've got a problem with what you've tried to done, and Python has just said, nope, not having it, and has denied your request to do the task at hand. And so in my case, it's denied printing this off. These errors are very, very helpful. And a lot of the time, if you take the error, you copy it. In this case, I'm just going to copy it like this name error : str8 is not defined, and you just paste it into Google. You're almost always going to have on Stack Overflow be the top hit. And if you click that, very often you will have the exact reason why, let's go ahead and just accept all cookies, you are getting the error if you read on down the list. Sometimes with more common, simple errors like this, you might have to pop around a little bit, but essentially you'll eventually come to somebody explaining why this problem has happened. In this case, someone's given the answer, your code has different flaws. You can go through, read the question, see if the question is similar to what you're experiencing. A lot of the times their code will be right here. This is a little bit more complex than what we're dealing with right now. And then what you'll have are a bunch of different answers. The top answer is usually the best because they're upvoted. And again, you might have to look at a couple different Stack Overflows, but eventually you'll find that you can debug and solve a lot of your problems by using Stack Overflow or just Googling a bug or Googling a question. So what does this mean? Well, it's a name error, which means that this str8 is not defined. What does that mean? It means that we haven't created str8 in memory. Well, have we? We got it right here. And the answer is no, we haven't. And the reason why we haven't is because of case sensitivity. Python is a case-sensitive language. It is very important that you learn this right now because it will solve a lot of your problems down the road. If you have an object and a variable created in Python, it needs to be called with the exact same case. So let's go ahead and just real quickly, let's create str8. And we're going to say, this is a new string. We're going to execute that cell, and then let's print off str8, and we see that it's a brand new string. So Python is a case-sensitive programming language. And again, don't worry about the code so much right now. We're focused more on concepts here. So go ahead and play around with that for a little bit on your own, and when you're ready, pop back because we're going to be talking about what data actually is. Okay, so what is data? Well, believe it or not, I'm going to tell you right now that data in and of itself has absolutely no value. It's completely useless. It doesn't do anything. It just sits there as a bunch of zeros and ones on your computer. But at the same time, you might have heard the expression that data is the new oil. Well, what does this mean? Well, data is the new oil means that data is this new hyper-valuable thing, this new commodity that can be leveraged for monetary gain or some kind of development across the world. How do we rectify these two disagreeing statements that data is useless and that data is the new oil? Well, it's quite simple. Data in and of itself doesn't really have any value. It's useless. It's when you apply data or analyze data or connect data to other pieces of data that we start to get the utility of it. Data is only useful if it can actually be discovered, found, leveraged, used, and applied in some capacity. In this chapter, we're really going to be talking about what data is and what data terminology you need to know to work with it in Python. And then in the next chapter, in chapter 4, we're going to talk about data structures, which is where you take this random pieces of information and start maybe taking them and working with them and putting them into some kind of structured form. That's going to be where data has its utility. That's where you find that data is actually useful. And that's why data is the new oil. It's only when you take it and make it relative to other pieces of data. So what is data? Well, data is anything. Really? Everything is data in some way, shape, or form, depending on how you think about it and how you define it. But what I'm going to talk about here are really kind of the main 4 types of data that you're going to need to be familiar with throughout this textbook and really with all your Python work going forward. And there's also going to be, as we're going to see, 3 different groups of data structures that you need to be familiar with as well. So the first thing are strings. Now, a good way to think about strings are just text. From here on out, associate the word string not with that thing that you might have like that looks like yarn, but think of strings as a sequence of characters that make up text. We're going to talk about how you create a data object that is a string in just a few minutes, but let's go through and talk about the others first. The next thing you need to know is integers. What is an integer? Well, an integer is a whole number. It could be like 1, 2, 3, 4, 5 on down the list. Floats, on the other hand, are different. A good way to think about float, it stands for floating point number, is as a decimal point. If your number has a decimal, it's a float. The reason for these need to be handled differently is because of how whole numbers, integers, and floating point numbers are handled in memory. They're handled a lot differently because this is done at a binary 0-1 level. It's beyond the scope of this textbook, but you have to start understanding and thinking about numerical data. So data that deals with numbers as either being an integer or a float. This is going to be true across, I believe, most, if not all, programming languages. The next thing that you need to be familiar with is Boolean. Now, this comes from an older, I think it's 19th century form of algebra called Boolean algebra. It's essentially an algebraic way of thinking about the world in a binary manner. What does that mean? It means that everything is either 1 or 0, on or off. And Booleans in programming are going to be true or false. Something is either true or it is false. It is either a 0 or it is a 1. So Booleans are a way of working with data that is binary, something that is either true or false. And this is important. It's a back cornerstone to all computer science because essentially computers, with the exception of the more advanced, newer quantum computers that are kind of becoming the rage in the hard sciences right now, all your computers, the one that you're working with right now, are binary. They function at a 0-1 level because of how they work at the hardware level, and that's beyond the scope of this video, but essentially this is why Booleans are so essential. And as you're going to see, especially as we get to loops and conditionals, when we start working with computational logic, Booleans are essential for working with data by setting up logical statements that allow for you to do things to them. So Boolean, true or false. Now we're going to meet data structures in the next portion of this video in chapter 4, but for right now, understand that there are these things called lists, tuples, there's other things called sets, and there's dictionaries. Again, don't worry about them right now. We're going to meet lists, tuples, and dictionaries in the next chapter, but for right now, let's go down and just start talking about what strings are. So let's pop back over to our handy dandy notebook right here. So we've already met strings a little bit, believe it or not. The str8 in all of its different forms was a string. So we're going to make now officially our first formal lesson on creating data within Python and creating data within memory. So let's do this first with a string. Now you cannot name something string, or I think actually str, I apologize. You cannot name something str because this is a sequence of characters, a variable that is saved for use in another way in Python. We're going to see why in just a little bit, but for right now, do not name your string or str. It's bad form. While you can do it, you shouldn't do it because it'll override a function that already exists. Again, we'll talk about all that later. So let's maybe call something string1, okay? And we're going to use the equal sign. Now what we're doing here is we're creating an object and a variable. This object, whatever we create, is going to be called string1. That's going to be the variable name that we use to reference it later in our Python program or later in our Jupyter notebook. We're then going to use the equal sign. Now what we're doing here is we're telling Python, okay, this sequence of characters, this is going to be, that's what this equal sign is going to be this piece of data. Now, the way in which we define a piece of data in Python is going to be very different depending on what kind of data we want to create. If we want to create a string, we have a couple different options. We can use a double quotation mark, followed by another double quotation mark. And you notice that my notebook automatically does this. Yours might not, and there's no problem with that. For right now, don't worry about it. But you're going to have an open and a close double quotation mark. So on a Western American PC, this is going to be Shift and the button to the left of the Enter or Return key. Now, what I can do within this is I can type a sequence of text. This is some text. Now, when I execute this cell, or I hit Shift Enter, or I just hit the play button up here, that piece of data, this string, is now stored in memory, as we saw above, and now I can interact with it. Now, in a Jupyter notebook, I can do string1, and it'll send the output down here. But if you try to do this either in the terminal, or sorry, in another form, like in a Python script, you're going to get an error. And so if you just do string1 like this, or you won't actually be able to see it printed off, you want to use print. And this will allow you to print off this, this string essentially. And so that's how you know that you were successful. Go ahead, pause the video, and try to create a string right now by mimicking this. And don't follow with my text here. Make up your own string. Have fun with it. Maybe write a little short poem about Winnie the Pooh. I don't know. Make it up and have some fun. Pause the video and pop back. Okay, now that you're back, there's another way that we can make a string in Python. This is important to be familiar with out of the gate. So again, we're going to say string2 now. So this is a new object. We're going to use an open and a close single quotation mark. Now, in this, we can say this is another bit of text. And I can go ahead and execute that cell. And I can print off string2. And I'll print off that. Now, what we're seeing here are two different ways of structuring a string with a double quotation mark and a single quotation mark. Now, why is this important? Well, it's important because as you start working with data inside of data, you're going to eventually come to the point where you have to work with a quotation mark that is within a string. And so there's a couple of ways to get around that problem, but one of them is to use different quotation marks, and you'll be able to actually use whatever that quotation mark is inside of your actual quote or your string. It's beyond the scope to explain that in depth right now. That's a little advanced, but for right now, understand that you have a couple different ways of creating a string, and you might see, and the reason why I'm including it here is not because this is something that you should do, but you might see this in someone else's script. You might see something that looks like string3. Let's do that. Be a little consistent, and you can say something like this. I've got, if you notice here, 3 quotation marks. This is a third kind of string. And I can print off a string3. Let me zoom this down just a little bit for you. And I've got it. This is a third kind of string. So my point in all of this is that it doesn't matter which kind of quotation mark that you use. You're going to find that you have your own way of doing it. A lot of people will use a single. I happen to always use the double. And you start to get this fingerprint of your code. You can identify someone's work through, not just like you can with language, but you can actually identify someone else's code because we tend to have these forms that we stick to and these conventions that we use. But as long as you're consistent, pick one of these forms and kind of stick with it. Don't do the triple quotation mark. This is typically reserved for special circumstances, but pick either a double or a single quotation mark and stick with it. If you're inconsistent, you're going to have problems. So let's say I want it to create another string. I'm going to have a double quotation mark as the opening to it. So this is a bad string. And then I'm going to close it with a single quotation mark. Now, on the surface, this seems like it should work just fine. I'll execute that, and it won't even let me create the object. Why is that? Well, I've got what's called a syntax error. Now, a syntax error occurs when there is a problem with the way or the syntax in which you're trying to create an object or do something in Python. So a syntax error means that I've not created an object correctly. And this EOL while scanning string literal is really hard to parse, and that doesn't make any sense at all. But if you were to copy this into Google, you'd probably find out that you have to be consistent with your opening and your closing of quotation marks, which means I have to close with the same thing that I opened it up with. So now when I try to do that with a double quotation mark, I can print off string4, and it works just fine. So let's talk a little bit about maybe some other pieces of data now. So that's going to be our string. So if we pop back to the textbook, kind of covered a lot of this already. And now we get down into numbers. Now, numbers, if you're coming to this video like I am as a humanist, you might be thinking to yourself on the surface, why would I ever need to work with numbers? I don't think about things quantitatively or numerically. I think about things like text. I care about text. I don't care about numbers. Stop that line of thought right now, because you'll be working with numbers no matter what kind of data you use, you will be working with numbers because the numbers allow for you to structure logic. They allow for you to structure more complex things like certain kinds of loops. They allow for you to work with data in a different way that's going to be absolutely necessary, even if you work with text. So you might need to know, if you're working with text, for example, you might need to know which word in a paragraph you're at. That's a number. That's a quantitative thing that you need to know. Numbers are going to be absolutely important, and it's important now that you stop thinking about numbers in this single way, right? So you might think about things as imaginary numbers if you do more advanced mathematics and regular whole numbers, but what I'm talking about here is think about numbers as either integers or floats. There are other kinds of numbers in Python as data, but we're not going to really talk about them in this textbook. For right now, we're going to just think about numbers as being either integers or floats. So let's go ahead and create a number in our Jupyter Notebook here, our YouTube demo. So if I wanted to create a number, let's call this int1. Again, do not use int by itself ever. This is something that actually has a function in Python. Let's call it int1, which is going to stand for integer 1. Much like before, we're going to create this object or this variable with an equal sign, just like we did with the string up above. Unlike before, we are not going to use a quotation mark. Instead, we are going to use just a number, just 1. We're going to execute that cell, and we can print off int1 just like we did with the string, and follow along, try to do this yourself, and it works. We don't have an error, we have an integer here. Now, this is really, really useful stuff. It means that I can work with this piece of data differently than what I would do with a string. And we're going to see why that's important in a little bit when we start trying to manipulate pieces of data, specifically strings and numbers. But let's pop back and take a look. So that's how we get an integer. Well, how do we get a float? Well, let's call this float1. Again, don't use the word float. You'll notice that this pops up as green because it already has a role in Python. We can say float1 is going to be equal to 1.1. We can print off float1, and it prints off 1.1. Floats and integers are both made the exact same way. Python will automatically identify the period, the decimal point here, and automatically assign this as a floating point number, a floating number. So it'll automatically find this and identify it and structure it differently in memory. And that's very, very important. So the other kind of data that we have are Booleans. So what's a Boolean? Well, a Boolean is just a very fancy way, and it's a word you have to get used to using. I say it wrong constantly. I say Boolean. It's actually Boolean. Somebody's probably already typing in the comments and correcting me. It's one of those words I learned to say incorrectly, and now I can't say it correctly. Sorry, it's Boolean, not Boolean. And so what a Boolean is it allows for you to structure a binary thing, a true or a false. In Python, again, remember, is Python a case-sensitive language? Take a second and think about that. The answer is yes, it is. So we can't use the word bool in Python, but let's say Boolean1. We're going to make this equal to, no quotation marks here, the letter T, R-U-E. And that's how we create a true Boolean. So if I were to print off Boolean1, we see that we actually get true printed off. The other thing that I can do with a Boolean, it's only one other option here, is I can make a Boolean called false with a capital F. Again, it's very important that you're using capitals here. If I print off Boolean2, I see that I've printed off false. So in each of these cases, I've kind of created a new object in memory and given it a variable of a different unique name, and I can print it off later in my script. We've seen us now create 3 different categories of data, but 4 different kinds of data: strings, integers, and floats, which are both numbers, and Booleans. Now, why is this important? Well, once you create data in memory, you really oftentimes really need to work with it in some kind of systematic way. So what I'm going to do is kind of walk you through some of the main ways that you need to be familiar with how to kind of work with this data. So a lot of the times if you're working with textual data, which I do all the time, you need to do some very basic functions on it. So what are some of these basic functions? Well, let's take a look at one of them. Let's create an object. We're going to say this is name. I'm going to say William Mattingly. I'm going to create this in memory. So one of the things that I might need to do to this is maybe I'm going through a text and I want to, for whatever reason, capitalize the string William Mattingly. So I'm going to do print off. I'm going to say name.upper. So name.upper, an open and a close parenthesis. Now, notice very clearly right now that we've got the print function, which requires two open and close parentheses, followed by the name.upper and its own open and close parentheses. If I print this off, we see that this string, or this sequence of text, my name, is now completely uppercased. Now, that might seem kind of simple. Why would you ever really need this niche scenario? I can tell you that this is going to be, actually, you're not going to use upper. You're going to use something a little different. You're going to use name.lower. Take a second. What do you think this is going to do? Print it off. It's going to lowercase everything. Now, why is this useful? Well, here's one scenario. Imagine if you needed to search for a string within another string. Now imagine if I wanted to check to see if William appeared in this text. Now let's say it goes on some text after that, and then all of a sudden there is, for whatever reason, one piece of data in this long string is spelt a little differently. Well, if I were to print this off now, I would notice that I've gotten William spelt two different ways. If I wanted to look and see how many times William occurs within this string, again, remember, Python's case sensitive, I would only see that the answer is once. Because if I were spelling with a capital W, it would only find this one. If I spelled it with a lowercase w, it would only find this one. But if I wanted to search to how many times William occurs, regardless of typographical error, then I would need to search across a lowered string. This is why you need to start thinking about text as data. Now, we're not really going to get to this scenario just yet, but this is why simple functions like this allow for you to do very complex things. They allow for you to clean data, structure data, and make it where you can analyze it in a more systematic way. And believe it or not, I use .lower quite frequently. If we keep on going down the list, we also have .capitalize. So let's create a new object called name2, and I'm just going to call this William, because apparently I'm very egotistical and only using my own name. So we're going to print once again, and we're going to do name2.capitalize. And again, an open and a close parenthesis here. We're going to print that off, and we notice that William is now capitalized. What the capitalize method does is it allows for us to automatically capitalize the first character in a string, in this case, William, the W in William. So that's going to be what capitalize does. If we keep on going on the list, we got more fun things that we can work with. And again, I'm kind of going through these a little quickly, so if you need to, pause, play around with these on your computer, and then pop back to this video. So the next thing in this textbook is the replace method. So replace is pretty cool. Let's say I want it to print off name2. And for whatever reason, I don't like the IAM at the end of William, and I want to go by Will. Now, I would never do this in a million years. If anyone ever calls me Will, they're most likely trying to not be nice. So if I do .replace and I do an open and a close parentheses, I will try to execute this and I'll get an error. Now, why have I gotten an error? We go down. We'll notice that I got a type error. Now, the type error is really useful because it tells you pretty clearly what you need to do. So we haven't learned about this new term, arguments, yet. So what's happening here is I'm getting a type error because the replace method expects at least 2 arguments, but it got 0. So what's an argument? Well, an argument is something that you would put within this parentheses. So the open and close parentheses. Arguments are going to be separated by a comma. Again, if I executed this, I would have invalid syntax. So I have to put something here, and I have to put something here on each side of the comma. These are both going to be strings, which we create with either an open and a close double quotation mark or an open and a close single quotation mark. Now, what I'm going to do, and this order is very important, this first string will be the thing that I want to replace. This second string will be the thing that I want to replace it with. So let's say I wanted to get rid of the IAM in William. I could print this off. And because I've got nothing here, what this is saying is the first argument, the thing that I want to replace, what Python is doing is it's going in, it's grabbing this string in memory. It's looking at it and says, okay, this guy wants to take it in. He wants to say anytime IAM appears, it needs to be replaced. And it needs to be replaced with nothing. What if I wanted to change it to something else? So I could say space is not my name, period. And I could print that off and it could be something new. What we're seeing here with all these examples is something called string manipulation. This is really the cornerstone of working with data. 90% of my time in working with data isn't actually doing some complex machine learning task or analyzing it in some statistical way. 90% of my time is just spent taking in data, cleaning it, and structuring it. While that might not sound like fun, it becomes a massive puzzle. And that's what really makes programming a lot of fun, is that at the end of the day, all you're doing as a programmer is you're trying to find a lazy way to computationally or through your computer perform some kind of task. And the puzzle is, how do you do it? And there's not always one right answer to this problem, but you can get kind of creative, and that's the fun part of programming, is figuring out that how question. How do I do a task at hand? So let's keep on going on down the list and really look at a few different things. So if you look at this paragraph here in the textbook, we are going to encounter some new terminology: immutable and mutable objects. So if we look at this print function here, I've got name2 $place I am with is not my name. Now in theory, I should be able to simply print off name2 now, and it should still be the exact same. And it's not. It's gone back to how it was before. It doesn't have the capitalized form. It doesn't have this replace in there. Nothing's changed with name2 in memory. Why is that? Well, this comes back to two words that you have to learn now because they're vital to your progress through Python. That is immutable or immutability, spelled like this, and mutable. So objects in Python are either immutable or mutable. Now, what does that mean? It's just a fancy way of saying changeable or unchangeable. So a mutable object is something that you can change and update in memory. An example of this will be a list, which we're going to encounter in chapter 4. An example of an immutable object is a string. In order for you to change a string, you have to replace it in memory. So if I did something like name2, again, I'm creating a new object called name2, so I'm replacing the old one in memory, and I were to make that equal to name2 dot replace IAM with, and again, when you're writing code, speak out loud. I always do to this day. It's not my name. Now if I were to print off name2, I've got it precisely what I wanted to see. Will is not my name, period. If I wanted to capitalize it, I can create a new string 2 called name, or new name2 called name2, make that equal to name2 dot let's just say capitalize, and I can execute this cell and I can print off name2, and I've got it now as a new option. So what's going on here? Well, in Python, what I'm doing in this line is I'm saying, okay, we're going to create a new object name2. I know we already have one, and we're going to replace it. And we're going to replace it with the previous name2, but with this change happening to it. And what's really cool about Python is that you can stack these in a single line of code. So you can play around with this a lot. So let's create a new object called name1. Again, we're going to call this one, we're going to replace it in memory because we already have a name1. We're going to say William is my name. And then what I can do is I can say name2, let's say name3 is going to be equal to name1. We're going to dot replace Will with, maybe your name is Tom for whatever reason, or maybe it's something else. So you can say dot replace William Tom, and you can print off. We can print things in the same cell too. So let's go ahead and do that and print that off. And it says Tom is my name. Well, fantastic. Now, what do you think? Pause the video. Don't cheat. Pause the video. What do you think will happen if I do this and I execute the cell? What I've just told you is true, that I can stack these up. Pause the video, take a guess. Okay, was this what you expected to see? Tom is my name, all lowercase. If it was, then congratulations. If it wasn't, think about what's happening from a logical point of view. Programming languages are sequential. They go top down and left to right. At least in the Western world, I'm not sure about programming in where you were working with in right to left language. But in the Western world, what you're going to typically do is work top down, left to right, unless you're doing more complex things, which we'll get to later in this textbook. So let's work through what's happening left to right. Well, we've got one object we're creating called name3, and that's going to be equal to name1, which is right here. And we're replacing this bit of code right here. And then we're going through and we're doing dot lower. Now, what would happen if after this then I did dot upper? Take a moment, pause, and take a guess. Is that what you expected? I hope it was, but if not, let's explain why. So in memory, we've lowered the string, but then all we've done is we just replaced it with dot upper, so we've uppercased it. So by the time it gets to the print function, which is right here, it's gone through all of these different steps. And we can do this exact same process by doing name1 equals name1 dot lower, or name3. And then we could do, actually, let's do this. We can take this and print things off sequentially. So let's do print name3 like this. I'm going to go ahead and delete this for right now. So we see it like this, where it's just printing off name3 with that replaced. Let's then print off, name3 is equal to name3 dot lower. We'll print it off at that stage, so name3. Okay, so now we have Tom as my name, and we see it now change with dot lower, and then we're going to do name3 equals name3 dot upper. We see that it's, we got to print it off. And we see that it's changed once again. So what we're doing here is we're manipulating the string sequentially. And that's important to remember. We're doing it step by step. At each level, from a top-down point of view, the string is changing in memory at each one of these stages. So we're not changing the string, we're simply changing it entirely in memory by replacing it entirely. So strings are mutable objects. If you go through in the textbook, you'll get a deeper description about all of this. But I want to show you a couple more tricks that you can kind of do with a string in Python. And again, these are very, very useful things I use every day. So let's create a new string. We're going to have what's called a leading white space. So this is something that has a space right before it. Now, if we print off name5, we will see that white space represented right here. If I were to do name5 this way, where you can actually see the data a bit more clearly, you'll see that white space is still there. What we can do in a lot of cases when you're working with strings in Python, these white spaces will cause a lot of problems with unclean data. Oftentimes you want to eliminate leading and trailing white spaces or things like line breaks and such. And so one of the things that you can do is you can use .strip, which is going to take no arguments. It's just going to be this right here, and we can print off name5. You'll notice that we've eliminated that white space at the beginning. We can do name5 this way, and you can see that it's gone. What strip does is it eliminates both the leading and the trailing white space. So let's just go through this again. We'll see that we got this trailing white space here. We can do the same thing. And we notice that the strip has removed the leading and trailing white space here. A strip can do a lot of things. You can specify what to strip, but that's the main function of strip. Now, really the one other thing that I really want to talk about in this portion of the textbook, working with strings, is this dot split. So dot split is pretty cool, one of my favorite things. It will allow for you to split a string if you don't give it any parameters whatsoever. Oops. Looks like I went back up to the original name1. Let's go ahead and we'll just leave it like that. And so what you're able to do is to split. Now, by default, what split will do is it'll split at a white space. So let's go ahead and take a look at this. Let's create a new string, call this name6. That's equal to William Mattingly. So what do we have? If I were to print off name6.split, it's going to split at the white space, eliminate it from our data because we're splitting there, so it's taking it away and splitting it up. And what we see as an output is something that you haven't seen yet, but you'll be familiar with by the end of the next chapter. What you have is a list. In this case, a list of strings. So split allows for you to actually separate things out. And what's pretty cool is split can do some other things like, let's say if I wanted to, I can have a string that's 3 words long, and I can tell it to split the first argument will be what I want to split at. In this case, I want to split at a space. And I can do a second argument of only do that one time. Only do it at the first instance of a space. If I wanted to split the text at every time there is an I can do it at the first instance. Or what I can do is I can pass just one argument and split the text up anytime that there is actually an I in the text. So I can split up the whole string this way. Splits, not something that we're going to be working with for a few more chapters, but it's really good to know about it. And the reason why we're going to be working with it a little later is because you really need to know about lists before we start working with split, and we start doing some fun things like indexing, which we're going to meet in the next chapter, which is when you can really kind of index and point to a specific point in a list or any kind of data. So that's really the main things that you need to know right now about working with strings. Now, I know this chapter is a little long compared to the other ones, but I wanted to talk about really kind of working with numbers as data. So there's a lot of different things that we can do with our numbers. So in Python, remember, Python's really kind of useful for doing a lot of mathematical permutations on data, and maybe in other fields as well, like the hard sciences. And so you can do all these different things in Python to work with data, from addition to subtraction, multiplication, exponential multiplication, so to the nth power, division, modulo. This will return a remainder. So if you try to do like 2 divided by 7, the remainder, the bit that's left after 2 divided by 7, so 2 goes into 7 3 times, with the remainder being 1, so 6 plus 1 equals 7. You can do a floor with a double slash. This will return the max number of times you can divide. So 2 divided by 7 would return 3, because 2 can go into 7, a max number of times of 3. So how do you do these things? Well, let's say I've got an object called num1, which is going to be equal to 1, num2, which is going to be equal to 2. So I can do num1, I can do print off num1 plus num2. And I get 3, because 1 plus 2 is 3. I can print off num1 minus num2. And I get -1, because 1 minus 2 is -1. I can print off num1 times num2. So 1 times 2 is, in fact, 2. I can print off num1 percent num2. I get 1. I can do print num1 floor num2. Oops, and I wrote this a little backwards. It's 7 divided by 2. Will leave us with the answer being 3. So it goes 2 goes into 7 3 times, and 7 modulo 2 would be 1, because your remainder after that is in fact 1. So this is how you kind of do basic mathematical operations within a Python script. If we keep on going through the textbook, though, what we'll find is a couple other sections right here. And again, I'm only introducing these right now just because it's important to be familiar with them, because we're going to be working with them a great deal later on. This is how you do comparison operators, such as equal to with a double equal to sign or equal sign, greater than, less than or equal to, or greater than or equal to, or not equal to with an exclamation and an equal sign. Again, I'm only talking about these here briefly just so you're familiar with them, because we're going to be working with them a whole bunch when we get to conditionals and loops, and really part 3 of this textbook. So that's going to be it for this portion. I know we covered a lot here, but hopefully you have a better sense about what data is, what the 4 kinds of data that we're going to be working with in this textbook. And if you want to kind of quiz yourself, go ahead, and at the bottom of the textbook, each chapter, you're going to have some quizzes that you can do. These are very simple. If you want to suggest new questions that can be added, or you see a mistake, let me know in the comments down below and I'll update it. While I can always update the textbook, I can't easily go back and update the video. So now we're going to be diving into data structures. Now, in the last chapter, remember I talked about how data was actually kind of useless, and it really wasn't useful until you put it into some kind of structured way. Think of a database. That's going to be what we cover in this chapter. Now, what we're going to be covering, there's a lot of different types of data structure out there, especially when you get into computer science, not just in Python. There's linked lists. It's really complex, but there are really 4 that you're going to find that you need time and again in Python. These are going to be lists, tuples, sets, and dictionaries. Sets, lists, and tuples are all very similar, but we're going to see those differences throughout this chapter. And dictionaries are going to be fundamentally different. The great thing about a dictionary is something is to something else. Again, we're going to learn about all of these, and we're also going to learn about indexing. So what is a data structure? Well, a data structure is just a way of storing multiple kinds of data in some kind of systematic way and making them relatable to one another. So the first thing that we're going to look at is this thing called a list. Now, if you know what a list is in English, you probably already know what a list is in Python. So let's create an object called list1. Again, we don't name anything list in Python. Don't do that. We're going to make that equal to, because we're creating a new object or variable here, and we're going to use an open and a close bracket. This is very important. This is what makes a list a list. So when Python sees an open and a close bracket, it's going to see a list. So let's go ahead and add some stuff into our list. So let's say we want to make this list a list of maybe a couple different random things. Let's say the letter 1 or the word 1. Let's go ahead and load that list up into memory. Let's print it off and see what it looks like when we print it off. It's a list. Sure enough, it prints off a list. Well done. Let's say we want it to maybe make this a little different. Let's say we want to have 1, 1, and then we can have 1.0. All different ways of representing the number 1 as a string, as an integer, and as a floating point number or a float. And if we print that off, we see that we have all these here. So a list is a sequence of things stored, and if you notice, all these things are separated by commas. What's pretty cool is that you can have a nested list or a list within a list. So I can have 1, 2, 3. I can save that, and I have a nested list. This is the power of a list. You're going to find that lists are one of the things that you use most frequently because you need to store lists of data in different ways. It can be a list of strings. It can be a list of numbers. Lists are going to become something that you work with every single day. The other thing that is looking kind of similar to a list, but is a little different, is called a tuple. Tuple. Now, this is going to be made a little differently. It's going to be made with an open and a close parentheses. Now, you're just going to have to memorize how you create these kinds of data. So how is this different? Well, let's go ahead and make one right now. 1, 1. Let's make it the exact same, actually. Let's make it 1.1 so we can identify the difference. Print off tuple 2. So what's the difference between list 1 and tuple 2? Well, they look very similar. They just have an open and a closed parentheses, and the other has an open and a closed bracket. Well, the difference is, and this is very important, one is mutable and the other is not. Lists are mutable objects. What does this mean? Well, list 1 is 1, 1, 1.0, and this list of 1, 2, 3. Because an object is mutable in memory, this means that I can add to it, change it, do something to it in the memory rather than replacing it. So I can do list1 dot append. Now what append does is it allows for me to add something to a list. So I can append, let's just say 500. Now if I print off list 1, I'll notice that I've got 500 added to it. I haven't replaced it in memory, I've changed it in memory. And that's a big difference between what we saw with a string. If I try to do this to tuple 2, I would get a name error. So why do I have a name error? Oh, well, I have a name error because I haven't defined it correctly. Tuple 2. I now have an attribute error. And the attribute error tells me tuple object has no attribute append. This is because append changes something in memory, and a list is something that can be changed in memory while a tuple cannot. This is really going to be useful if you're doing more robust things, but it's important to be familiar with this distinction. Now, there's one other thing that looks like a list, but isn't a list. So let's go ahead and create what we're going to call set1, an open and a close squiggly bracket. So this on a keyboard, again, if you're using an American standard keyboard, it's going to be Shift and then the button above the bracket. It's going to be right next to the P on an American English keyboard. And that's going to make a squiggly bracket. You're going to have to get very familiar with where this is at because it's used for a lot of different things in code. And if you're programming in C, you'll know that it's a very standard thing there, JavaScript, etc. So what does set do? Well, let's try to make 1, 2, 3, 4, and then we're going to make 1 again. Now, if I try to print this off, you'll notice that I don't have this extra 1 right here. Why is that? Well, a set functions rather like a list or a tuple, except that a set cannot have more than one of the same piece of data. So if I were to change this to 1.0 and print it off, I would notice that it doesn't let me do it because 1.0 and 1 are essentially the same thing. What if I try to do 1 like this? Well, in that case, it would work just fine. So a set is a way of making sure that all of your data is actually stored as a single time in some kind of data structure. Now, let's talk about one other kind of data structure here. And again, in the textbook, we go through the difference between mutability and immutability. And that's going to be our dictionary. So what is a dictionary? Well, a dictionary can look very, very scary if you're not used to coding, but it's a very powerful concept when it comes to data structures. So let's call an object called dict1. Now, think about a normal dictionary. We might have a word, like in English, we could say the word hello. And then maybe our dictionary, think about an English to German dictionary, it's going to have the word hallo. So hallo in German is hello. If you print off dict1, we see that hello is set to some kind of value of another word, allo. In programming terms, this would be a key and this would be its value. So think of a dictionary like this. It is a key, colon, set to a value. Now this is really important. Let's say that we had a dictionary called dict2. We're going to make this equal to an open and a closed squiggly bracket. And we're going to say names. We're going to have a colon. We're going to have an open and a close single bracket. So what is this going to tell you that this kind of data structure is? The value here. If you said list, you would be right because it's an open and a close bracket. And this could be a list of names. So we could have, let's say, Tina, Jerry, Bob, Marge. Why not? I can print off dict2. And I can actually have a very kind of structured way of representing my data. So again, this is the power of a data structure, is it allows for you to take data that is not connected to each other and make it connected in some way. Because this collection of random pieces of data, this Tina, Jerry, Bob, and Marge, these are just random strings. But when I put them in a dictionary, those strings now have meaning. They are the value of the key names. This is essentially what a database is. It's a bunch of keys that correspond to different values. This is the power of data. This is when it starts to go from this thing that doesn't have any use at all to being something that's powerful, something that you can monetize, something that you can use for your own purposes. So those are the really kind of 4 main data structures that we're going to be working with throughout this whole textbook. Now, there's one other thing that we need to talk about in order to reference things, and that is going to be indexing. So indexing is going to be important to understand because we do it in every single Python program that we write. It's a way of grabbing a piece of data from another piece of data. So we can do an indexing, for example, with a string. Let's call an object string8, str8. So I've created an object called str8. This is a string. I can print off str8. And we see that, in fact, it is a string that we can print off. So indexing is what we do when we want to grab a specific piece of data within another piece of data. So I would do an open and a close bracket, and this is going to be a number. If I print that off 0, it prints off t. Why is that? The answer is because I have indexed the string at its first position, or 0. So this can be a little confusing when you're coming to Python for the first time or programming for the first time, But when we work with data, we index things starting at 0. It's a 0 index language, which means that the first thing in any data structure or piece of data is the index 0, and then it goes up. So if I were to print off str8 1, what do you think would be printed off? I'm going to let you pause the video here and take a guess. If that was your answer, then you'd be right. We got H, because in the first index, it's the second position in this string. What's cool about indexing is that we can do it with a lot of different things. We can do it with all kinds of data. Let's say, for example, I wanted to go up here to list 1, and I wanted to grab index 0. That would be this right here, the string of 1. So I can print off list 1, index 0, and I get the string of 1. I can print off list 1, index 1, and it gives me the number 1. So I can keep on going down this list. It allows for us to grab a particular point within a piece of data or a particular point within a data structure. So the way in which we index dictionaries, though, is going to be a little bit different. We index dictionaries at their keys, not at their position. So the order of keys doesn't matter. Dictionaries are essentially orderless. So we can have names and we can have ages, a second key in our dictionary now, and we can make that equal to another list, and we can have, we can say 20, 22, 23, and 24. So these are going to be the ages of these individuals. Let's go ahead and create that again in memory and replace the original dict2. So if I were to print off dict1, it would look like, dict2, it would look like this. So if I wanted to grab the index here of names, I would do the same thing, an open and a closed bracket. But if I were to try to do index 0, I would get a key error. And what this key error tells me is that there's no key in the dictionary called 0. There is, however, a key called names. If I try to do names, again, I'm going to get a name error. Names is not defined. We don't have a variable name names. We do, however, have an index because we have a key called names within our dictionary. So if I print off the dictionary, dict2, at the index of names, it's going to print off the key or the value that corresponds to that key. If I were to type out dict2 and index the dictionary at ages, what do you think would print off? Take a second, pause the video, and think about it. If you said 20, 22, 23, and 24, you would be right because it prints off at that particular value. So this kind of is a quick introduction to essentially lists, tuples, sets, and dictionaries, different kinds of data structures, and different ways of indexing data. So you've learned a lot of new concepts here. Go ahead and spend some time with this, create your own data, and then when you get back, we're going to start really working with kind of the crux of Python and any programming, which is essentially logic. And like I said, at the end of this chapter, there is a quiz you can kind of go through and test the ability or how much you've actually learned from all of this. I encourage you to spend a good deal of time working with data and data structures and becoming familiar with the Python syntax, or the proper way to structure your Python code. So in this portion of the textbook, we're going to start working with kind of logic statements, or ways in which we can work through data in some kind of systematic way. There's two ways that I'm going to cover in the next two chapters, including this one, 5 and 6. The first one is going to be loops, which are a cornerstone for all programming languages, and another cornerstone for all programming languages, which is conditionals in chapter 6. So covered in this chapter, really, what are loops? In Python, we have two different kinds of loops. We have for loops and while loops. We're going to talk about those. And we're also going to talk about what iterations are, what an iteration is, and why loops are important. So let's go ahead and move back over to our Jupyter notebook, and let's start working through what a loop actually is. So what a loop allows for us to do is it allows for us to iterate or move over a piece of data. So let's create a temporary list right now. Let's call this list, let's call it list 5. And this is going to be equal to a list of names. So actually, let's just call this names. Why not? And this is going to be, let's say, Tom, Marge, Bob, and Cindy. So if I were to iterate over names as a human, I might manually go ahead and print off Tom, print off Marge, print off Bob, and print off Cindy. And I could realistically do that. I could write out 4 different print functions and do that. The problem is it really feasible or realistic to do that if I have a list of maybe 1,000 names? And the answer is, of course not. And so what we do is, instead of iterating or moving across our data individually as a human, we tell the computer to do it for us. So imagine if I wanted to print off a list of 1,000 names, I'd have to have 1,000 print functions. But a loop is an easier way to essentially automate or do that task. Now, the way in which we introduce a loop in Python is first going to be with a for loop. So I can say for, and again, say this out loud as you type it. For, I'm going to say name. I can name anything right here. I'll talk about what this is doing in just a second. So for name in names. So what this bit of code here means is for each, I'm going to create this temporarily in memory, this object name for each item essentially in this list. So in names, colon, this is going to say, now this is what I want you to do for each of these. Notice now something looks different. We have an indentation. I hinted at indentation in chapter 1, and this is what really makes Python easy to read as far as programming languages go, and easy to debug. Not all programming languages require indentation. Python does. And notice that I have a colon right here. What a colon does is when Python's going through and reading your script top down, left to right, when it gets to the colon, it's now expecting an indentation. And so the next line will be indented. Depending on how you're writing your program out, it's probably going to, in the environment that you're using or the IDE that you're using, it's going to automatically indent for you. And what we see here is the ability now to do something within the loop. And so for right now, I'm just going to say print off name. So what I'm doing is I'm creating this object temporarily in memory. It's the piece of data that it iterates across. And if I execute this cell, it'll print out each of these names. So this is really cool. I can iterate or move across a data structure. That's wonderful. And I can name this whatever I want. I can name this item. So for item in names, print off item. And it's going to print off each item. This is really, really useful. It means that I can do a task, like let's say I had a list of 1,000 names. I can do a task in a single collection of code to every single thing consistently. So let's say I wanted to change name temporarily in memory. I could say name is equal to name. I could do .capitalize. So these names aren't really kind of structured in proper American English syntax. They should all be capitalized. And now I can go ahead and print them off. And I've got each name now capitalized. So imagine if I had a list of maybe 1,000, 10,000 names, and none of them were capitalized. Now, as a human, I could go through in a text file and maybe manually change each one of those. But if I know Python, I don't have to do that. I can just go in, automate over everything in the list and change it. And then, as we're going to learn later in this textbook, I can save that to a new output file, a new text file that's now got cleaned, structured data the way I want to see it. So this is the power of a for loop. Now, the other kind of loop that we have is called a while loop. Now, a lot of the things that you need to do in Python, you can do with either a while or a for loop. But there are certain instances when you should really use one over the other. And again, this is going to be something that you kind of get a feeling for over time. A while loop will do something so long as that item is true. A for loop will do something for a given time frame, given a particular condition. In this case, for as long as there is an item in the list, a for loop will continue iterating across that item. And it'll continue doing this new thing to whatever it is. A while loop has to have a condition to not be true in order for it to break. So I think the easiest way to understand that is to see it in action. So I'm going to create an object called x. This is going to be the integer of 0. So I will say while x is less than, remember we were talking about these operators just a few chapters ago. While x is less than, let's say 10, print off, actually we're going to do x, Let's do print off x. Do not execute this yet because it'll be an endless loop because x will always remain 0. I can say x is equal to x plus 1. So what's going to happen is so long as x is less than 10, x will be printed off until x is equal to 10. So what happens here is at each loop, each time it goes through, I am printing off, or I'm sorry, I'm adding 1 to x. So if I were to print this off and execute it, it'll go all the way down, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Because at this point in the loop, we're started off at 0, x has been added up to 10. And at this point, the loop breaks. Because at this point, x is now not less than 10. So what if I set it up a different way? I said, while x is equal to 0, or 10, I get a syntax error. Why? Well, again, if we go back to our operators that we learned about, we know that equal has a very special role in Python. It creates an object for us, the variable. And if we want to do equal to, we simply do equal to 10. Okay, so nothing prints off because 0 is not equal to 10. What if I wanted to say, while x is not equal to 10? And again, it's going to be doing the exact same thing. Now the question is, why is this the same as this? Why do we have the same result? Well, it's because as x is going up and ticking up each time through the loop, it's eventually going to be 10. So while x is not equal to 10, the loop will continue to run. But as soon as x equals 10, the loop breaks. So while loops do something so long as, or while a condition is actually true. So that's going to be really the two kinds of loops that you're going to encounter in Python. So why are loops useful? Well, they allow for you to manipulate data in a systematic way or do certain tasks repetitively until something happens. So what you're going to find is that you never really do something in Python where you just change one piece of data with one line of code. Typically, that's not necessarily a good use of time because you could just change it manually yourself and have that result done. You use Python, as I said in the intro to this entire video, that you use Python to do automation or perform tasks that you couldn't do as a human, to automate things, to do things in a collective manner. Loops are a cornerstone for how you achieve that. So I encourage you to spend a little bit of time. We're going to be using loops throughout the rest of this textbook. We're going to see more advanced things that we can do with them. But for right now, maybe play with a for loop for a little bit and try to do different things to each of these pieces of data. Maybe try to uppercase them. Maybe try to uppercase them and then lowercase them and then print things off. You can do a lot of different things with a for loop. Just focus with them and play around with them for a little bit. You're not going to break your computer. You might enter a position where you create a while loop that'll be running continuously, and it might lock up and freeze your internet browser. If it does, that's okay. Just close the browser and open it back up and restart. Essentially what you've done in this scenario is you just created an endless loop that's continually to run in memory until it runs out of memory. It's not a big deal. You haven't broken your computer, but it will cause things to freeze up. But I encourage you to play around with this. You're not going to hurt your computer or break it by doing anything in this environment right here, especially if you're doing this in the cloud. It's not going to do anything wrong to your computer because everything's being done on a server remotely. This brings us to our next kind of logical statement that we need to work with in Python, and that's something known as a conditional statement. It's a way that we can structure logic conditionally. So long as, if something is something, then do this. If it's not, then do this. It's a way of structuring kind of these if-then conditions within Python. Every programming language has a way of doing this because you always want to do certain things upon certain conditions. And I think the best way to really kind of understand this is to jump in and explore it for ourselves. So we're going to be walking through really kind of three different main components for conditional statements, and we're going to be learning a lot more about operators, specifically the and operator and the not and operator, what they mean and how to use them. So a conditional has three components. It has if, and then it can have else, and it can have elif. This is going to be where we kind of start today with this video. So let's go ahead and create an object. We're going to say x is equal to 0 again, And so what we're going to do is we're going to start off saying a condition. If x is equal to, remember, double equal sign here. If x is equal to 0, then print off x is 0. So what do we have here? Well, we have a conditional statement. We have if, and notice the green syntax here, space, x is equal to 0, colon, and what do you expect after a colon? That's right, an indentation. If x is equal to 0, then print off this statement. Well, what if we make x not equal to 0? What if we make x equal to 1? Nothing happens. So what we could do then, if we wanted something to happen, if this condition was not met, we could say else. So if that doesn't happen, if x is not 0, then print off the statement x is not 0. So what do we have here? Well, we have an else statement, which means if this condition is not met, then we have a colon, which means then do this, whatever occurs in the indentation below. So if we execute that cell now, we see that we have printed off and triggered this condition. So conditionals are a great way to structure some kind of robust logic. Now on the surface, it might not seem necessarily useful right out of the gate. Why would you really need to do that? If you're just coming to code, it can kind of be difficult to fathom the utility of this. Well, imagine we had a list of names. So again, we're going to go back to our same one again. We're going to say Tom, Bob, I think I have this right, Marge, and Cindy. I think I've used the similar names up above. So what I can say is if, let's say I wanted to know if a person named Jerry is in names. So if Jerry in names, so what this says is if Jerry is in this list, notice this new thing we were just learning about, the in operator. So if it's in that item, that piece of data, then print off Jerry was found. And nothing prints off. So this is a way that I can use a condition to actually check a real-world piece of data to know if someone is included. And then I can say, well, if he's not, then let's change names in memory. Let's say names.append Jerry. Cool. Now, if I print off names, I've now ensured that Jerry is now in that list by structuring a condition, because when it first ran, this occurred. If we were to run this cell again, it's going to say that Jerry was found, because at this point in the Python script in our memory, Jerry has now been added to that list. So the other component that we can really work with is something called elif. So a good way to think about elif is, if you're familiar with other programming languages, it's like or if is a good way to think about it in English syntax. So if, let's say now, let's say Bill is in names, print Bill is in names. Elif, or if Susie, I spell Susie, Susie is in names, print Susie in names. Else, print neither found. So if I were to execute this, what I'm doing now logically is I'm looking and saying if Bill is in names, then print off Bill is in names. Elif, so or if Susie is in names, then print off Susie in names. Otherwise, if none of these are found, else print off neither is found. So that's going to be how elif works. It works as a second condition. And remember, Python is sequential. So what elif allows for you to do is to structure some kind of robust, really kind of robust things. So what if I wanted to add in another elif statement? So let's say I wanted to add in elif, and I'm going to say if Cindy is in names, do that. Well, oh, helps if I do this. There we go. Cindy is in names. So if it goes down the list, when it encounters a condition finally met, or if Cindy's in names, do this, or if Susie in names, do this, notice that else hasn't been triggered. What elif allows for you to do is to structure a series of conditionals. So else means if none of these conditions, if none of these elifs or ifs are true, only on that condition do you actually print off neither is found. Now, that's how the and operator works, and that's how conditionals work. But let's say that I wanted to have the opposite of that. I could say if Bill not in names, print Bill is not in names. So I can use the opposite, not in, to look and see if somebody is not in the list. So not in and in are the opposites of each other. So they allow for you to check if something is within another piece of data. So that's going to be how conditionals work. They allow for you to structure logical statements. And I know I haven't really covered a lot for this chapter, and there's not a lot to actually cover. Conditionals become easier as you start working with coding more and you start using them. You'll find that they're actually a very natural way of writing out logic because we speak with conditionals in everyday language. We say if this is true, then that has to be the case. If you did this, then I won't buy you pizza. You know what I mean? There's conditions that we use in everyday life, and there's conditions that we can structure in code. Think of them as extensions of your own language and as ways of structuring logic, and you'll find that they're pretty simple and straightforward to use. You can have nested conditionals too, where you can check to see if multiple things are true against nested conditionals. So if Cindy not in names, then print off Cindy not in names. And you can kind of go through and do all that. So we can also structure a name if, let me think of another name, Xena, warrior princess, right? If Xenon is not in names, then print that off. And so what you're able to do is to structure these kind of nested conditionals. And because this is not in there, then the next layer conditional has not been triggered. If I change this to Tom, then it would trigger that logic, which would then trigger the next logic. This is getting a bit ahead of ourselves right now, but I simply wanted to include it just so you're familiar with the fact that you can have nested things within other nested things, and there's a lot that you can do with conditional statements. I encourage you to spend a good deal of time playing with them, structure your own conditions, and see what you can kind of do with Python. Again, you're not going to break your computer here. So just play around with it and everything will be just fine. And the best way to learn here is to experiment. You're going to get errors. If you get an error, ask a question in the comments down below, or just, go to Google and Google it and you'll find the answer. It's now time to start moving into some more advanced features with programming in Python, and that's going to be functions. So this is kind of the beginning of what we would consider more formal coding. Up until this point, you've really kind of done everything just in a Jupyter cell. What we're going to be doing here kind of going forward is structuring our code in a more formal way. And the way that you do that is going to be by creating what we call functions. Functions allow for you to do a lot of different things in coding, and we're going to be talking about them throughout this chapter. We're going to be talking about a couple different key components to a function, including arguments, variable keyword arguments, and variable arbitrary arguments. We're also going to be talking about how to create a function and how to implement it and the kind of functions that exist that you should be creating in Python. That's going to let us then in the next chapter talk about another kind of formal coding concept called a class, which is a more robust kind of data structure that can contain functions within it. And then we're going to be talking about libraries. By the end of this formal coding section of the textbook, you're really going to have an idea about how to leverage Python to do much more complex things and maybe solve really kind of particular tasks that you have. That's going to set us up for the second half of this textbook, which is going to be when we start working with more realistic external data. So let's go ahead and just start talking about functions right now. Well, what is a function? A function is a way of doing a task repetitively, but in a more systematic manner. A function is a thing that allows for you to pass what we call arguments to it, and then it will either do something to data and return a new piece of data, or it will do a task and then simply execute that and finish. I think the best way, after you read this textbook, is to kind of see functions in action to get a sense of what they are. And believe it or not, you've already seen a couple of these, and I think you'll recognize them. So let's create a function and let's just do something really, really basic. We want a function that will allow for you to add, or maybe let's just say multiply anything that you give it by 3. So let's call this function multi3. Nothing really, let's call it multiply 3. Let's call it that. Why not? So what I do is I create a function by using def for defining the function. Then I give the function some kind of name. In this case, multiply underscore 3. And then I have an open and a close bracket. Now, I have a colon. And if you know what's going to happen after the colon, good for you. An indentation. Everything that occurs in the script at this indented level is going to be part of the function. So I will say that this function is going to take one argument. There's one thing that we want the user to pass to this function, and it's going to be the thing that we want to multiply by 3. So let's just call it x. Why not? A common variable. Okay, so within this function, it's going to take an x. First, let's just see what this function looks like if we just print x off. So in this case, we want the function just to do something. So I'm going to go ahead down here, and I'm going to say y is equal to multiply 3x. Now again, remember that our function doesn't actually multiply by 3 yet. We're just going to have it only print something off. And we get an error. What was the error? Apparently multiply. I have misspelt multiply. And now anyways, if we correct the error, we see that it works just fine. So what this function does is it takes an x and it just prints it off for us. In this case, x was already defined up above as 1. What if I wanted to pass in a new argument here? Well, I could pass in 6. And in this case, the function's going to take in 6 and then print off that variable. So what our function does at this stage is it just prints off x. Now, we typically have a function do kind of more complex things than just printing something off. We typically have it execute some kind of series of commands or change the data in some significant way. So let's add a new line, and we're going to say x is equal to x times 3, because remember, our function's going to multiply by 3. So we use x is equal to x times 3. We're just going to print it off, and it prints off x. Now, what if I wanted to print off x down here? It's still printing off as 1. Now, why is this the case? Because x has been defined earlier in our script. The x that exists here within this function only exists within this function unless we do some special stuff to make that not the case. One of the things that we can do is we can return x out. So instead of printing x, let's just return x. So our function will take an x, it will change it here, and then it will return it. Now let's print it off. Well, we've got y created, but let's see what happened to x. X still hasn't changed because x doesn't change because it's only within this function. However, if we were to print off y does work. Why does that work? Well, what we've done is we've created a new object that is the result of passing something to this function. So what we've done is we've created an argument right here that is now temporarily x, and the function is simply changing it for us and returning x out. So that is essentially how a function works. It'll take in some kind of data and it will change it in some capacity. So at the end of the day, your functions should be doing something in your code for something else. Let's create another function, and this function will just be to maybe add two numbers together for us. So let's create a function called add2, and then we want this function, because it's going to add two numbers together, we want this function to have an x and a y, so two different numbers that the user can pass to the function, and we want this function to have a result which is equal to x plus y. So the goal of this function is just to add two numbers together. And we're going to return the result. So now, if I were to do add 2, I could do, let's say n is equal to add 2. And we're going to pass in two numbers that we want to add, 5 and 6. And we can print off n. And the result is 11 because our function takes in two different arguments, and the result is that. If we were to try to execute this code with only one number, and we go down, we've seen this error before. We've seen it before when we were talking about the split function, type error. It requires, or sorry, the replace function. A type error tells us that add2, our function, is missing one required positional argument. Why? Because we haven't given it 2 arguments. So this is when you have multiple arguments in a function. It's going to be when a function requires 2 different things. However, let's say we had let's go ahead and execute this so the error goes away. There are other kinds of arguments that a function can take. In some cases, a function might take what we call keyword arguments. These are going to be arguments that kind of are specified by default, but can be changed by the user. So let's make a new function called, let's call this add surname, or, add last name. So we're going to have the first argument the user presents is the first name, and the last name is going to be Mattingly. Why not? So now what the point of this function is to simply print off whatever the user gives. So we're going to print off first name, comma, last name, which will allow us to print off 2 different things back to back. So we're going to say add surname, and we're just going to pass in William. And it prints off William Mattingly because we have a keyword argument, which we've defined right here with an equal sign. So it's got this default value already there. This is essentially what a keyword argument is. I can pass in a new last name, and it'll print off William Smith because this positional argument, this item in the second position, which is the keyword of last name, has been replaced by whatever I have specified. There is, however, a different kind of argument, and this is called an arbitrary argument. It means that you can pass in kind of anything that you want of any length. So let's say we wanted to, and this is really good for demonstrating with a list. So let's say we have this function called print names, and we can use an asterisk names. And again, this is a little advanced. I'm only including it here so you're familiar with the different kinds of arguments that exist for functions. This function will say for name and names, print off name. So we can create this function and execute something within it by saying print underscore names. And let's just say William, Marge, and Kyle, and then let's say Sally. Why not? If we do that, we print off all these different conditions. So what an arbitrary argument is that there's an arbitrary number of things that will exist under this category. And so that's kind of the function of the different kinds of arguments. What I recommend you do is spend some time with some very basic functions. And again, this is an introductory course. Get familiar with the syntax, get familiar with the indentation, get familiar with how to create a function, how to use it. Make a function do something particular to maybe a use case scenario in your own field. But pause the video here and play around with functions because we're going to see them again in the next chapter when we start talking about classes. So now it's time to talk about another kind of formal coding, and that's known as a class. So what is a class? Well, a class in Python is a more advanced kind of data structure that allows for us to kind of structure data in a little bit of a different way. We're going to be seeing a class, and I think the best way to really kind of understand what a class is just to see how it works. And what a class is essentially a data structure that allows us to perform kind of specialized functions on it as we kind of go through a Python script. So let's go pop back over to our live coding notebook over here. And let's kind of take a look at how we make a class and how we can kind of create a class to do kind of some elaborate things. So first of all, a class is going to have a couple different components. First of all, it needs to be called out by using the word class. And what this class is going to do is it's going to really work with data that we're going to see in the last part of this textbook, which is working with imperial data from Wikipedia on emperors or kings of France. So we're going to call this class emperor. There we go, capitalized E. Remember, it's all case specific here. And the first thing that we're going to have within a class is def. Now, hopefully you remember what this is. This is a function, and every class is going to start off with this init function. It's underscore underscore init underscore underscore. It's beyond the scope of this video to really kind of talk in depth about what this is because this is, again, just a beginner's course. But understand that this is going to look like this at the start of your function. We're going to have self, which is going to reflect back to the initial input data. then we're going to have the kinds of things that we want our class to actually have. So the different pieces of data that a class data structure will have. This allows us to have some specificity about the data that we actually are working with. So we're going to have name, birth, coronation, and death. So our class of emperor, this data structure, is going to have these 4 components: name, birth, coronation, and finally death. Within this, we're going to do a couple different things. First thing we're going to do is say self.name is equal to name. And this is going to allow us to kind of structure the data structure within this function here. And then the next thing we're going to do is self.birth. This is going to be equal to birth. Self.coronation, or coron. We're going to make that equal to coronation. And self.death. And that's going to be equal to death. Now, this is what how a basic class will essentially look. It allows for us to kind of go through and structure how the data should be structured. So let's go ahead and just save this for right now, actually, and call this class. So the first thing I'm going to do is let's create an object called Charlemagne. This is Charles the Great. He's a Carolingian king, someone I studied. And so what we're going to do is we're going to call the emperor class, and we're going to pass in 4 pieces of data. And they're going to be in order that we expect to see them up here. So the first is going to be name. This will be Charlemagne. The next will be his birth year, which is 742. There we go. And then the next thing is going to be the year in which he was coronated. So this is the coronation year, which is going to be 800. And then finally, it's going to be his death year, 814. And if we do this and we print off Charlemagne, we'll notice that we have something that looks like this. Now, this might look kind of scary at first, and there's a lot happening here. But essentially what we're looking at is a special kind of object in memory, a class object. Now we have a couple different ways of accessing this data. So let's go ahead and try one of those ways. We can print off vars Charlemagne, and we can get access to that data. Now you might be thinking to yourself, what's the big deal here? All I'm looking at is just a dictionary. Why couldn't I have just made a dictionary for this emperor and just called it a day? Now, at that point, you would be really right. Essentially, all this is a dictionary, right? It's defined with an open and a closed squiggly bracket. It's got a key of name, value of Charlemagne, key of birth, value of 742, and it goes on down the list. There's nothing particularly special at this point. And that's where the class comes in. Now, the way in which you'd create a class is typically to do functions upon the input data to change it in some capacity. Now, you're going to be using functions probably when you get a little bit more comfortable with Python. They tend to be a little scary at first, and that's fine. I'm including them here so that you are familiar with them, know what they are, so when you look at someone else's code, you'll know what's happening. But let's try a very basic function within this class that we can actually do. So within this class, we're going to have the function, let's call it, I'm going to follow the textbook here, birth_date. It's going to take in the self object, which is going to be all of this data initialized at the init function. So all this data here. And then what we're going to do is we're going to use that data to print off a string. Now, as of Python, I think it's 3.6 or 3.7. Python's on like 3.9 with experimental 3.10 right now. You have what's called an F string, a formatted string. And this allows us to do some special stuff. We can say Charlemagne, or what we can actually do, my apologies, we can do an open and a close squiggly bracket, which means that whatever's in this part of the string is going to be an actual variable. So we can say self.name was born in, and we can say self.birth. So this is the special function within our class. So again, if we execute this code, we can go through, and again, nothing looks that different. But what I can do now is, because I've got this set up as a function within the class, I can now call it as what we call a method. So I can print off, sorry, I can actually just execute Charlemagne dot birth date like this. And what it'll do is it'll go into this class, which is a special data structure that contains all this information, and it will perform a special customized method or function within the class and execute it with a dot birth date, and I can call it after the variable. So essentially, a class, conceptually, is a way of structuring data in a traditional data structure, but with the added ability to have functions that happen within it. So this is really useful when you're working with hierarchical data that will need to be manipulated in some capacity consistently by a user. Oftentimes you're going to see classes, when you look at what we're going to meet in the next video, different libraries in Python. When you first start off with Python, you probably won't be using classes too frequently. They will, however, become a staple when you start to try to display your code or put it out on maybe GitHub or demonstrate it or create a library all on your own, which we're going to talk about in just a few minutes. Now it comes time to meet probably one of the most important things that you'll meet in this entire video on Introduction to Python for Beginners, and that is libraries. So up until now, we've really worked with code that we've kind of just created ourselves. But you'll find as you start trying to do more advanced things, it can take a lot of code to do something that you want to achieve. And this is where libraries come in. Libraries are essentially ways that you can leverage code someone else has already written, install it onto your computer, and load it into your own Python script to do something kind of special. So what I'm going to do in this video is kind of demonstrate a couple different things. One, I'm going to talk a little bit about external libraries, the ones that are out there, the ones that we're going to be using in this entire textbook, and I'm going to show you how to install them and how to import them into a Python script. All these are important, necessary steps to become familiar with. So first things first, how do you actually install Python? Well, if you're using a notebook, you can use an exclamation mark and pip. So what pip is pip is a way that you can download and install different libraries that contain different code. What we're really going to be working with in this video, or in this entire textbook, are 3 different libraries: Pandas, Requests, and BeautifulSoup. So what you can do is you can use pip, or a Python's package manager, to automatically go through and download for us all these different libraries by doing pip install pandas. So let's see what that would actually look like. So I would do first pip install pandas. And what pandas is, we're going to meet it when we work with tabular data. It's a way of working with tabular data in Python. I have a whole video series on that, but we're going to be talking about it at a basic level later in this video. We also can do pip install requests and pip install BS4, which is BeautifulSoup, which is really going to be what we work with throughout this entire textbook. So with BeautifulSoup requests, or I'm sorry, BeautifulSoup for BS4 is a little different. BeautifulSoup 4. So what all this is it's a way of actually working with different libraries that have different functions and different classes built within them that allow for us to leverage those functions and classes already designed to do code that would take maybe 300, 400 lines of code to do. It allows us to do them in maybe 1 or 2 lines of code. So libraries will save you an immense amount of time. Once you've installed a library, you import it by using the import command in Python. And again, I document this all in the textbook. I'm going to cover it very briefly here because we're going to be working with libraries throughout really the remainder of this entire textbook. And you'll see this again and again. So if I wanted to import requests, I would use import space the library name, import requests. I can also do import pandas as PD, and that'll import it as this name here. And then when I need to call a class or a function within this library, as we're going to learn about in practice in a few chapters, I can go ahead and call the libraries natively by just doing pd.dataframe, for example. Again, we're going to see all this in practice. This little brief video or snippet of the section of the textbook is just to explain briefly what libraries are, how to install them, and how to import them. As we kind of go through, I will be reiterating some of these steps and covering them in a lot more detail. But before we get to that, I really want to jump into something that you're going to have to use on a regular basis, which is working with external data. And that's going to be the next part of this textbook. So now in this video, I want to start talking about working with external files. The vast majority of the time that you work with Python, you are not going to be working with data that you create within the Python script by manually typing it all out. Most of the time, you're working with data that is stored in some kind of external file. In this part of the textbook, we're going to cover really kind of two kinds of data. Textual data stored in a text file, JSON data stored in a JSON file. We're going to talk about JSON files in the next part of this video in chapter 11. And we're also going to cover working with multiple files using the glob library that comes standard with Python. In the next part of the textbook, we're going to work with tabular data, known as really kind of usually our .csv files. And we're going to talk about that because the way we work with CSV files requires a little bit of a larger knowledge about another library called Pandas, and so we're going to treat that separately. So for right now, let's go ahead and just talk about text files. So within this repository, or the place I have all this data kind of stored, I have a data subfolder. Now within the subfolder, I've got a couple different text files, sample, sample2.txt. Let's go ahead and take a look at these. So sample.txt has 3 lines in it. This is a sample line of text. This is another line of the same sample text. This is a third line. Again, the stuff here doesn't matter. Oftentimes, a text file will contain maybe a book, maybe a chapter of a book. Maybe each line will be a name in a list. There's really a lot of different ways text files are used. You'll find that if you're familiar with Word documents and you're always a Word person, you're going to find yourself using .txt files really a lot more. And there's a reason for this. .txt files are very lightweight. They allow for you to store data pretty quickly, pretty consistently, and pretty easy to kind of verify visually. If you have a line stored on each, if you have a name stored in each line, it's pretty easy to scroll through and make sure that each one of those is in fact a unique name. But what we're going to do now is we're going to start working with this data within a Jupyter notebook, or really kind of any Python script you might be writing. So I'm going to go ahead and remove this for right now. We are going to be working with now something that we haven't seen yet. And this is going to be the with operator. Now in Python, there's a few different ways that you can open up a Python file. If you look at a lot of tutorials out there, they're going to give you something like f is equal to open, f.open or something like this, where you can open up the file this way. This is bad form. Do not open a file this way because you have to manually close it in your script. And if you forget to, and you have a loop going on, you open up 10,000 text files, you're going to have 10,000 text files opened up in memory. This can, if you don't have a lot of memory in your computer, this can cause your computer to crash. So that's a big problem. The way we get around this is by using what's known as the with operator. A good way to think about with as, with this file open, do this task, and then as soon as that portion of the code is done, close that file. In other words, what with does is it allows for you to open up a file and close it after your task is done automatically, so that you don't run the risk of having kind of memory overload on your computer and your computer crashing on you. So within with, we are going to pass in, create an open and a close parentheses. And so what we're going to pass here is, got ahead of myself. We're going to say with open. So with open, and then we need to specify with what we're opening. So open in Python allows for us to open up a file. So in this case, we're going to say pass a string. We're going to say data \sample.txt. So what this is this is a string that corresponds to the location of the file that I want to open. Now remember, we're going into the data subfolder, slash, that's what the slash indicates. We're going to grab this file right here, this sample.txt file. And so what we're going to do then is we're going to pass in, comma, R. Now there's a few different commands here. We're just going to work with R right now. R stands for read. And we're going to open it up as F. And we're going to use a colon. Now, what this colon does, as you might expect, is it indents for us automatically, but it needs to be indented here because whatever happens within this indentation is going to happen with that file open. And so what we're going to do is we're going to open it up as F. So what this is doing in memory is it's opening up the file and storing this file temporarily in memory as F. And so let's go ahead, create an object temporarily called data, and this is going to be equal to f.read. Now what this is going to do is nothing on the surface. We need to actually do something with the data that we just read in. Well, what can we do? We can print off data. And what we've done is we've successfully gone in with Python to our directory, to our subdirectory of data, and grabbed this file, opened it up, and read it using f.read. Now in some tutorials you'll see fp here, and again, what that object is doesn't matter so long as you're consistent, and it's going to be the exact same result. F stands for file, and so that's just a good thing to always remember. What if you want to be Pythonic or kind of have code that is easy to read, stick with F or FP here and you'll be fine. So this is going to be what we can do. Well, we can do a little bit more with this file open. We can do f.read.split lines. And this is a common thing that you'll need to do. And what this will do, what kind of data structure does this look like to you? If you said list, then you'd be right. We've been able to go in and essentially create an output that is a list of everything separated at each line break. This is really important if you need to take in a text file that maybe is a list of names and automatically break it down into a list in Python. So this is how you work with external data. Now that's how you read data. Let's go ahead and print this off so we can see what it looks like. Okay, great. So let's go ahead and delete this for right now. Delete the split lines, just work with it as just this. So what we have here is we're just printing off the data as it is. Now let's say I want it to modify the data in some capacity. So I could say data is equal to data plus let's add in a couple extra pieces of things. Let's use /n. /n stands for, it's a way of saying a line break. So on a new line, write in this is a fourth line, and then print it off. And now we've got the data that looks like this. It's printed off as a fourth line. Now let's go ahead and try to write this file. Let's go ahead and write it to this file right here, sample2. Well, the way we write a piece of data to a file that we've got in Python is we can say with open, we can say the file that we want to write it to. So in this case, I want to write it to sample2.txt, and instead of instead of slash or comma r, we can pass in w. And what w stands for is write. And again, we're going to open this up as f, and we're going to say f.write, and then we need to say what we want to write. So we want to write data to that file. Now let me close this file, go back in, and open up sample2 now. And notice that we've now written our data to a file. This is very important. Oftentimes when you do manipulate your data in a Python script or in a Jupyter notebook, you need to save the work that you've just done. You do it by writing the data to a file. And if at any point you kind of get confused on this, kind of go back. It's important though that you remember that when you write to a file, it will erase everything in that file with whatever you've just added. So I often find it useful to write to a new file that doesn't exist so that I don't actually erase what existed on the previous file. That's how you open up, access, and work with textual data in Python. And we're going to build on this in the next video, or in the next portion of the video, when we start working with JSON data, which stands for JavaScript Object Notation. But for right now, pause the video and work with opening and creating text files all on your own. If you're just starting out with Python, it can be really scary to look at JSON data. I myself spent a good deal of time thinking that, I wouldn't need it, and I pushed it off far too long in my Python career, and I should have just gotten comfortable with it right out of the gate. JSON can be really scary when you're just coming to coding for the first time, but I promise you, if you spend the time now, get comfortable with it, you'll make your life a lot easier down the road. So what is JSON data? Well, JSON data stands for JavaScript Object Notation, and I cover this all in this textbook that you can kind of go through. A great way to think about JSON data is as hierarchical data. So it is a data structure and it's specifically a file that is readable and parsable by every browser because it's made for JavaScript, which is something that all browsers can parse because it's the way in which you kind of write code to interact with HTML, which is what you use to make websites. It's parsable by every browser, it's universally readable, therefore, and it's a way to pass structured hierarchical data. Now, if you oftentimes think about like data that you've seen maybe in an Excel spreadsheet, it might look something like this, where you've got like maybe one column that's text, one column that's names, but then when you start adding hierarchical data, so data that's linked to other pieces of data, it can get kind of confusing. Imagine trying to represent a list in an Excel spreadsheet in one column. Well, if you wanted to have a list of names that were found in this text, you might separate them out by commas. If you wanted to include other pieces of metadata about these people, you might store them as ages on this side over here, also separated by commas. It gets kind of messy. The thing is that tabular data in Excel are really good, but they're not great at representing hierarchical data. JSON, on the other hand, gets around this problem by working with data structures that are already implemented and used in programming languages, specifically JavaScript. But what we are doing is we're working with Python, and that means that our data is structured a little differently. Booleans in JavaScript will be all lowercase, but in Python they'll be uppercase. What the JSON library lets us do is it lets us take Pythonic data structures, such as lists, tuples, sets, dictionaries, and represent them and save them as a JSON file. So let's create a dictionary right now. Let's call this dict10. We're going to make this, actually, I think we already have, dict2 from up above. We have it. We have dict2 up above. Wonderful. So we've got this dictionary that we already made earlier in this video called dict2. So it's still stored in memory. And what it is it's two keys, names, which is a list of names, and ages, which is a list of ages. So what we need to do is we need a way to take this data and save this outside of Python. Now, you don't want to save this in a text file because a text file would be really hard to represent this hierarchy. You want to be able to save this as a JSON file. So the first thing that you have to do is you have to import the JSON library by typing in import JSON, all lowercase. Once you've done that, what you can't see is that this library, which comes standard with Python, is now loaded up for you so that you can actually leverage and use some of the built-in functions that come with the JSON library. So let's go ahead and say with open, we're going to open up a new file called data. Let's just call this temp.json. So we're going to open up this temporary file called temp.json in our data subfolder. And just for demonstration purposes, let's go back. And we'll see right now that this file doesn't exist. The sample_JSON does, but we're going to ignore that for right now. And so it doesn't exist. What we're going to do is we're going to create this new file by saying W, because we want to write to it. That's going to allow us to create it as well. We're going to open it up as F. Now, at this point, we need to essentially dump in or transfer in our data to this file. So what we can do is we can say json.dump, and this is going to take in a couple different arguments. Now, I always get these confused, so I'm going to go to the textbook and look, I can never keep the arguments straight. So the first thing is the data that you want to dump, the file in which you want to dump it into, and then indentation. We'll talk about each of these in turn. So the data that we want to dump is dict2. So this is going to be the data structure that you want to put into a JSON file. The next argument is the file that you want to put it in. In our case, this is F. So we want to put it into file F. And then finally, the indent is going to be equal to 4. This is an optional keyword argument. I always like to do indent is equal to 4 because it makes it a little easier to read. If we execute the cell, we have to go out of this and then pop back and we'll see that it's in there, the temp.json. So what has this done for us? Well, temp.json is now stored as a JSON file. This means that our complex data structure that we have in Python can now be stored externally. And that's really, really useful. JSON files can be as large as you want them to be. They can store really, really deep hierarchically nested lists within lists within lists within lists, or dictionaries within lists. They can do a lot. They can store really complex data outside of Python for you. Let's say, however, you want it to open up and read a JSON file. A lot of times, especially in the past 5 or 10 years, you'll notice that a lot of data is stored as a JSON file, and sometimes you'll need to open it up and read it in Python. So we can do that. Let's say you want to open up JSON. We can say data.temp.json. And instead of writing, we're going to be reading right now. So let's say R. We're going to open it up as F. And let's call this temp. It stands for temporary file here, or temporary data structure. We're going to say json.load. And we're going to pass in one argument. This is going to be F. It's going to be the thing that corresponds to the file that we want to read in. And remember, temp, we have not had temp as an object yet. If we execute that, we print it off, we see that temp is now loaded up. We've successfully now loaded up our JSON data. Now, you might not be using JSON data right out of the bat, right when you start working with Python, but you will be using complex data structures at some point in your Python career. Regardless of if you're working in the humanities and the hard sciences and the maths, you're going to be actually working with some kind of hierarchical data at some point, and you are going to probably encounter JSON data. I encourage you to spend time and think about JSON data a little bit more deeply and get comfortable with it and start kind of exploring it on your own. I have a whole series on my YouTube channel that talks about JSON data and how to work with it in more complex ways, but it really is going to be a cornerstone for kind of working with external data. You'll need to know how to use it, and it is one of the most important and universally accepted files out there for storing data. Now, in the next part of this video, we're going to be talking about how to work with multiple files at once. So now let's talk about how to actually open up multiple files. So this is a really common problem, and you might think that you just have to type in a whole bunch of different file names and open them up each individually. And the answer is no, you don't. And the answer for this comes from a very nice library built in with Python called glob, G-L-O-B. And we're going to also talk about how to do more complex things like working with walking directories in the Python library OS. A lot of Python videos that cover introduction to Python stuff will cover OS in a lot of detail. I'm going to gloss over a lot of it today to just kind of talk to you about how to use it to grab multiple files all in one go. So let's go ahead and jump over again to our working little Jupyter notebook here. Now, if we look in our data subfolder, you notice we've got sample.txt, sample2.txt. We got other, a subfolder with sample3.txt, and other2 with sample4.txt. What we're going to walk through is a couple different ways of grabbing multiple files in Python. First, we're going to be working with, though, the glob library. So let's go ahead and import glob just like this. It comes standard, you don't have to install it. So what we can do is create an object called files. And this is going to be equal to, and I make this mistake all the time, glob.glob, not just glob. I laugh because I constantly find myself wondering why I've made a mistake, and it's because I don't have glob.glob. So we're going to grab the data subfolder. Now, if I print this off, let's go ahead and print off files, I'll get data just like that. If I go like this, I'll get data like that. If I do .txt with an asterisk, something changes. What has changed here? Well, what I've done is I've added this slash dot, or this asterisk .txt. And so what this means is I want you to grab any file within this directory. If I just did this and printed it off, it would grab all of the folders, subfolders, etc. But by doing asterisk.txt, I'm able to grab just the text files from that directory. Why is that? Well, what the asterisk is here is it's a wildcard. So what it's saying is, in glob, go to the data subdirectory, the directory here, and grab any file in this directory that has an ending of .txt. And likewise, I could change this to just be JSON, and we'll grab all the JSON files. Now, why is this useful? Well, imagine if you had a directory with, and this is something that happens to me every day, I have a directory of 1,000 files. I can just use the glob library to grab all of those files really quickly. Now, there's other ways in Python to grab multiple files, and that requires more advanced libraries such as Path or OS, and you really don't need them 99% of the times. 99% of the time, glob will work just fine because a lot of your files are going to be in just one directory. But in some cases, you're going to have files that are in multiple directories. But before we get to that, let's think about why you might want to grab files in this manner. If I did, I can create a for loop. I can say for file and files, I can print off each file. Now, what does that mean? Well, if I can print off each file, I can open up each file too, right? So I can say with open, and instead of having to type out the file name, I can just pass in that same string of file, read as f, and then I can print off, or I do data.f.read, and then I can print off the data, which means I can go ahead and go in and print off all of that data. In this case, it's the JSON files. Let's change that to .txt. I can go in and print off and read each individual file. So if you've got a directory of 1,000 files, you can open up all of them in a for loop and almost instantaneously do some kind of permutation to, or change to that data, or print it off or analyze it in some way. So you will frequently need to access files, multiple files at one time in Python. So what if, however, your files are in multiple subdirectories? This is a common problem, and it's one that might not be very easy to solve right out of the gate. And I'm going to show you how to solve it real quickly, again, because this might be a niche scenario. Show you how to solve it in two ways. First of all, if your files are just in two different subdirectories, you could do files2 is equal to glob.glob data. So if I wanted to grab all the files here in other and other2, I can say asterisk slash, so any subfolder, .txt. And I can print off files too. So what this is allowing me to do is to grab those two subfolders worth of files and grab anything there. However, if I want to grab all the text files in an entire directory, I don't have a way to easily do that with glob. This is something known as walking the directory, or trying to navigate all of the different subfolders and finding all of them. All right, so let's go ahead and take a look at how we can do this. We can do it using the OS library, which is the operating system library, and allows for us to analyze our data structures in our subdirectories in a lot more robust ways. We can manipulate them. We can create directories. There's a lot of stuff that you can do with the OS library that you're going to get to in a later video when we start talking about intermediate Python, kind of some more sophisticated things that you can do within Python that you're going to be using probably for later programs when you start to kind of get and do more advanced things. So within this library, we've got a great class called os.walk. So let's create an object called walking, os.walk. We're going to just make this simple command here. And what that allows for us to do is to print off walking. Now, it's going to be a generator. Now, a good way to look at a generator is to convert it into a list. Again, I'm explaining this here so that you are familiar with a solution to a problem that you're likely to encounter. If we convert the walking generator into a list by using the list command, which takes in a data structure and converts it into a list for us, oftentimes used with generators, we can get an entire list. And we can go ahead and then kind of maybe think about this as a new object called walking is equal to list walking. And we can say for item and walking, we can just print off each item. And it allows for you to, oops, forgot I erased the generator when I converted it into a list. And you can kind of see what it looks like. So what this is each index in walking is a series of subfolders, or sorry, root directory and a series of subfolders and the files within those subfolders. Ignore this checkpoints item right here. This is a creation of Jupyter Notebook that allows for you to store checkpoints. So if you lose your work, you can kind of pop back from a saved checkpoint. So let's go ahead and kind of take a look at this. I'm going to copy and paste this straight from the textbook and just paste it into here. This allows us to actually essentially understand what our data looks like. So what we have is each item in this OS walking tells us the subfolder, or sorry, the root, and the files contained within it. So we know that the files contained within the data subfolder are sample.txt, sample2.txt, and the two JSON files. And we see that over here. Within the IPNB, again, we're going to ignore that. Within other, we see that we have one file, and within other two, we see that we have one file. So if I want to grab all of these, and again, I don't expect you to really understand the code here at this point, rather just understand that you have a solution at your fingertips with this textbook. You can go through and actually iterate over each of the items in these subfolders and grab all of them. Again, this is a very rare scenario when you need to do this. I've maybe only had to do it a handful of times. But it's here if you need it. Again, I don't expect you entirely to understand the code that's going on here because I don't intend to cover that in this textbook, rather in a later version that's going to include more intermediate stuff with Python, which will include the OS library in more depth and also the terminal. So this part of the textbook is just to give you a solution to a problem that might surface for you down the road. That's going to be it for this section though on working with multiple files. Again, learn the glob library. It's going to be your friend, but that's really all you need to know right now. And in the next section, we're going to start working with kind of something that's a cornerstone of all data, and that's tabular data, or data that would exist for you maybe in an Excel spreadsheet. Let's go ahead and talk about how to work with tabular data. Now in Python, there's a couple different ways to do it. In an older series on this channel, I talked about how to work with the CSV library, which stands for comma separated value library. I've kind of steered away from that with students now, and I typically teach tabular data purely through how it should be taught, which is through pandas. Now, I have an entire textbook available on pandas, so you can go to pandas.python humanities.com. And you can find all of it right here. Let me zoom in a little bit for you, and it's all available. What you're going to find covered in this portion of the video is really chapters 1 and chapters 2 from the part 1 of the textbook. And that's going to be kind of the basic stuff. I did a poll on Twitter to find out what people would find useful for their students to understand about pandas. And so that's how I'm kind of structuring this portion of the video. So what is pandas? It sounds kind of fun. It sounds like I might be talking about a panda, but in fact, I'm talking about one of the most powerful and widely used Python libraries out there. Pandas allows for you to work with CSV files. It allows for you to work with JSON files. It essentially allows you to take in data that is tabular in nature, meaning think of an Excel spreadsheet with columns and rows, and structure and create what's called a data frame. The data frame is the basis for pandas. It is a way of structuring tabular data in a special kind of object that can be analyzed, manipulated, and really kind of plotted even all in Python. It's a very powerful library, and unless you're working with really, really large CSV files or tabular data, and when I say really, really large, I mean in the hundreds of thousands of rows, Pandas is going to be the main library that you use to analyze this information. And the way in which you install it is by using pip install pandas. If you're working in the terminal, you can just type in pip install pandas. If you're working within a Jupyter notebook, you will do !, which means you're executing a terminal command, and you'll install pandas. Again, it is probably the most important library out there, and for doing any kind of tabular data analysis. And the way in which we import pandas, this is the Pythonic way of doing it, is with import pandas as PD. Now, I know I kind of rushed through all of this. If you really want an in-depth explanation of pandas, check out my entire video series on it. But for right now, we're going to just jump ahead and start working with the basics of pandas. So again, I've got the video here loaded up for this pandas basics from the original playlist and the textbook. So if you want to just kind of watch that one or go through the whole series, you're more than welcome to. But for right now, I'm going to kind of walk through this entire this chapter of this textbook, which is going to work primarily with this data frame, or with this dictionary right here, essentially a list of names. And we're going to do some analysis on this data frame and really start to analyze it through some basic pandas commands. So let's go ahead and say import pandas as PD. And I'm going to create this dictionary, which again is in our textbook. And then what I'm going to do is start trying to load it up within Python as a piece of tabular data. So let's take a look at it in more depth. Let's go ahead and in Python, let's print off names underscore dict, and we're going to index it. That's right, at the key of names, and we'll see that we've got essentially just a list of names. Now, this is fantastic, but what if we wanted to structure this as a kind of a more a tabular way? Well, the way in which we would do this is we would create the pandas data frame. Now, a great way to do this, the Pythonic or the correct way to do it in Python syntax, is to say df equals pd.data frame with a capital D and a capital F. And in our case, this is going to take one argument, which is going to be the data structure. So let's go ahead and do that. If we just do df, not print df, just df, we'll see that we actually have what looks like an Excel spreadsheet, right? We've got a series of rows which starts at index 0 and goes all the way up to 5. And we've got the column names of df. Now we can also print this off. You'll see it doesn't look as pretty within the Jupyter Notebook, but we still have the same idea, a series of rows in the column of data. So what if we wanted to save this data? So let's say we've got this dictionary, we've saved it, we've loaded it up, we've seen it, analyzed it as a data frame. Now we want to actually save it. Well, we could do df.to_csv data names.csv. And when we do this, we will see within this subfolder, we've got this new CSV file. So what's a CSV file? Well, a CSV file is a way to actually go through and look at your tabular data in a comma-separated value format, which means each piece of data is separated by a comma. Now, we'll notice one very highly problematic thing right here is that our column is not names right here. Rather, it's all of this stuff, these 0s to 5. Well, there's a really easy reason for this. We have to pass a keyword argument called index and set that equal to false. And when we do that and we go back, and if you're in Jupyter Lab, you're going to have to close the file to reopen it. And we go back, the files will now be stored correctly. So it's a common mistake that you're going to encounter when you're working with tabular data or CSV file data. So that's how you would save your data that you've got in Python to a CSV file. But more times than not, you need to actually open up a file. So let's go ahead and create a new object called df2. We're going to make that equal to pd, so pandas, dot read_csv, and we're going to call up that same file. And remember, this is a new object now, df2. If we print off df2, we'll see that we've successfully loaded it up. So if you have a comma-separated value file or just an Excel file that you can save as a JSON or as a CSV file, you can now load it up very easily all in Python. So we can also do the same thing with toJSON and readJSON, which I cover in the textbook, but let's go ahead and jump up to how we might maybe start adding data to our data frame. So a good way to think about your data frame and the way in which you would kind of work with it is kind of like a dictionary. So let's say we wanted to add a new key or a new column to our data frame. We can do this like this by saying df2, create a new column name. So in this case, it's called ages. We're going to make it equal to a list. Now in the textbook, I use the list here. I'm going to go ahead and copy this over actually, so that I make sure I get the same information down correctly. And we can add in a new column to our data frame, like so. So what we've done is we've just created this new, essentially, column called ages and added this new list to it. Now, you have to notice that the length of this list must match the length of the names column. Otherwise, you'll return an error. What's also pretty cool is that this is stored as essentially a special kind of object that we can kind of call in memory and kind of analyze in fun ways. So let's say I wanted to just grab only one column from the pandas data frame. Let's call this names. So I can say df2.names and then print off names. So if I take in a CSV file, I can get all the individuals in this names column. Likewise, I can do ages is equal to df2.ages and then print off ages. So I can analyze specific individual columns within the data frame, but this is difficult to analyze Pythonically because we can't iterate over it necessarily as a list. What if I wanted to take in all this data and I wanted to manipulate it in some way within a Python script or within a Jupyter notebook? Well, I can say ages is equal to df2.ages.to list, open and close parentheses, and then print off ages, and it's now stored as a list in Python. So this is how I can actually grab and analyze a column individually from an Excel file or a CSV file. Sometimes, however, I need to analyze something at a specific row rather than at the entire column as a whole. So let's say I really need to analyze whoever might be at column, let's say 2. So what I can do is I can say, let's say row 1 is equal to df2.iloc, an index at row 1, and then I can print off row 1. Row 1, and I can go ahead and I can grab a particular piece of data from row 1. In this case, it's Mary, age 6. So I can see different pieces of data within a Pandas data frame. So what Pandas allows for us to do is it allows us to use a library that can import really robust tabular data from an Excel file that's saved as a .csv file, and then analyze it either at the column or at the row level. Now there's a lot more that you can do with Pandas that I'm not going to cover in this textbook because I have a whole other textbook that you can go to learn all about it. I'm including it here mainly so that you can go through and know that Pandas is available to you as a way to work with external CSV files or comma-separated value files. What we're going to be kind of devoted to in the rest of this textbook is working with data that you might have on the web or HTML files, which really require a whole separate set of instruction. A lot of the time when we are working with data, it's not stored locally. Sometimes that data is stored online. What we're going to be working with in this last part of the textbook is really this last kind of practical thing that you really should be familiar with because you're going to need to eventually do it, and that's web scraping. Now, what we're going to cover in this portion of the textbook, chapter 15, is how to work with HTML, what HTML is, why it's useful, how all the websites on the web are built upon HTML, and really how to start kind of parsing it visually. And what we're going to be working through with is this website, Wikipedia. It's a list of French monarchs. And in the next chapter, we're going to be working with just grabbing all the different paragraphs. But eventually, in the last chapter, we're going to be working with kind of grabbing this table. So this is quite common. You'll be on a website and your data will be in a table, or your data will be on a web page, and you need to grab it. And you don't have the ability without Python to just copy and paste it over and grab this specific table. What I'm going to show you how to do in this last portion of the video is how to work with data that might be on the web, how to make a call to a server using the requests library, and then how to take in that request and then parse it using the BeautifulSoup library. So let's go ahead and jump back in our textbook right here because I think it's best to just kind of work through the textbook right now. So what is HTML? Well, it stands for Hypertext Markup Language, and it's the way in which websites are structured. And HTML is very hierarchical, which means it has something that might look like this. So this is a sample HTML file. In this case, it's a string right now for us, and it has different things called tags. A tag will look like this. So this is what's known as a div tag, one of the more common tags in HTML. And then it'll have a close tag, which will have this slash mark that comes before it. Anything that occurs between these two tags will fall between the div tags. And this is what I mean by hierarchical. So between these two div tags, we have a p tag. Now a p tag is what's used to delineate a paragraph. These are the two most probably common tags that you're going to encounter. And we're going to see why that's important. It's because that in order to scrape HTML, you need to rely on the structure of the website's HTML so that you can parse it correctly. So how do we create a tag? Well, a tag is created with this open caret and this close caret. So that's going to delineate a tag. And I think it's best if we kind of look for just a moment at a real website. And so this is our Wikipedia page. So what you can do is if you're using Firefox or Chrome, if you right click, you can hit this inspect button. And what you get is something that looks like this. Let me zoom in now. So what we're seeing here is real life HTML. So this is the HTML tag that opens up and it'll be a close tag at the very bottom. We see our div tags right here. We can see like things nested within a body tag. We can expand the body tag. And within the body tag, there's all these div tags. Within one of the div tags, there's an A tag. And this can quickly get extremely, extremely overwhelming. I'm going to walk you through step by step on how to do some web scraping, but first let's pop back over to our textbook and kind of keep on going on with kind of the lessons here. So we've got open tags and we've got closed tags, and we can see how we distinguish between the two, with a closed tag being this slash that corresponds to the same tag up above. And we understand now that you've got some tags nested within other tags. This is going to become very important when we get to chapter 17 and we start, or in chapter 16, when we start trying to extract structured data from an HTML file. So again, it's important to follow along with this textbook. Now, the next thing that you need to be familiar with, though, is within a tag, you can sometimes have what's called an attribute. An attribute will look like this. A very common attribute is going to be a class attribute. This is going to be something that looks like this within the div tag, or any tag. Class is equal to, in this case, an open and a closed quotation mark, content. And so this is a very common structure that you're going to see. Let's pop back over, and we'll see this in the wild. This div tag has an attribute of ID, which corresponds to content. It has a class of MW-body. That's the attribute class, and its class title is MW-body. And it's got an attribute called role with its title main. It's important to analyze these because when we start trying to parse HTML through BeautifulSoup, one of the things that you can do is you can specify the tags that you want to grab and scrape based on these extra attributes, which we're going to work through and talk about in just a few minutes. So that's kind of generally how HTML is structured at a very basic level. So how do you find a website's HTML? Well, like I said, if you're using Firefox or Chrome, you can right-click and hit Inspect, or you can hit Control-Shift-I on a Windows PC, and you'll be able to pull up this developer mode. And what developer mode allows for you to do is it allows for you to kind of go through and parse the HTML in real time as you kind of go through. One of the things that's cool about right-clicking, though, is you can right-click on a special component and you can keep on grabbing the nested part to what it belongs to. And so I'm able to actually go through and grab this specific tag right here. So I'm able to see that it is this paragraph right here that I'm looking for. And so this is really useful when you need to figure out what tag or what class something has, is to just inspect the specific item that you want to inspect. So were I interested in grabbing this table over here, this table of contents, I can inspect that and I can see, okay, this thing corresponds to these tags here. And I see, and notice up here at the very top, I can see things highlight differently as I kind of curse over different tags. So if I wanted to grab this entire, it's called the table of contents on Wikipedia, I would grab the div tag that has an ID that corresponds to TOC, or a class that corresponds to TOC. That's how I can specify a specific div tag to grab. And that's how I can kind of inspect different things pretty quickly without having to kind of do a lot of searching through the HTML. The inspection or developer mode allows for you to do a lot of things pretty quickly. So that's generally how this works. Let's go ahead and copy and paste this code though, and see how it works in code. And you're not going to understand what this is doing just yet. We're going to break it down and explain it over the next two parts of this video. So if I were to execute this, what I've done is I've used the requests library and the BeautifulSoup library to go to that website, look for and find the div tag that has an ID, an attribute of ID that corresponds to this particular content, and then grab all the paragraphs, the first 5 paragraphs from that, and print them off for me. Now again, if you don't understand what's happening here right now, by the time you get to the end of this video, you'll be able to parse this a little bit more. Web scraping is not something that you can just natively do. It requires lots and lots of practice to get really good at it and really quick at it. It is probably one of the more frustrating things that I've had to learn over my long Python career, but I promise you it's one of the most rewarding. There are other libraries out there for doing web scraping, but 90% of the things that you need to scrape can be done with requests and BeautifulSoup. The reason why I'm including them in this tutorial and not other methods such as Selenium is because A, Selenium is more challenging to install for new Python users. B, it's a little robust for just simple tasks like grabbing p tags. Selenium is better for like grabbing things that require you to log in or clicking buttons or engaging with JavaScript. It's a little bit more complex and is not necessary for every problem. And C, like I said, BeautifulSoup and requests is a fairly straightforward and simpler library to learn, and it also allows you to solve 90% of the problems that you're going to have. Whenever you do get into a problem that can't be solved with requests or BeautifulSoup, that's probably the time that you might want to switch over and start learning Selenium. But again, I think for beginners, this is a great way to kind of start working with web scraping. And over the next 2 sections of this textbook, we're going to start web scraping from scratch using requests and BeautifulSoup. So if you haven't done so already, I encourage you to go ahead and use pip to install requests and BeautifulSoup onto your computer. If you need familiarity on how to do it, you need to go up to the libraries chapter, chapter 9, and rewatch the video or go back through that and install those libraries. If you're working with this textbook in Binder, you've already got them installed in that environment because I made sure that the environment was structured in a way that they would be installed for you automatically. So again, this makes this a little bit easier for you. What we're going to be doing throughout this entire chapter is actually going through and kind of talking a bit about what these libraries are, how to use them, and what they actually do for us. So let's go ahead and, again, we've already imported requests, but just so you can follow along, we're going to import requests. Now, the website that we're working with is this one here, which again is provided in the textbook. Let's go ahead and start working with it from scratch. So we're going to create an object called URL. I always find this is very useful. This is going to be the link that I want to scrape. Let's go ahead and just create that object now. Store it in memory. So what we can do is we can create a new object called S. This is the way I learned how to do it a long time ago. Name this object whatever you want, or variable whatever you want, but I like to call it S, and we're going to call in the requests library, and we're going to use .get. We're going to grab the URL. So what .get does is this method allows for us to go on the internet automatically through Python and call this server and get a request from it, so we can actually work with the HTML that's loaded. If I were to print off S though, it's going to look something like this. Now on the surface, this looks kind of weird, right? What? Response 200. What this is this very specific code that tells you essentially that the request was successful. Some websites might have things that block you from using what's called a headerless browser. Essentially, the way Python is calling the server, it'll actually prevent you from doing that, and it'll return maybe a 404 error or a 400 error. Essentially, if your response is anything other than 200, there's probably something going on with that website that's blocking you from accessing it. And that means it's going to be a little bit more challenging to web scrape, and that's where more advanced tutorials, which I hope to put out soon on this channel, will come in handy, with more advanced ways of passing in headers to requests in BeautifulSoup, so you can get around some of these preventative measures on websites. So what we can do though with this response is, even though it looks like this, it actually has a lot of information in it, and it's got the entire website that we want to grab. So let's go ahead and use BeautifulSoup. What we're going to do is we're going to say soup is equal to, so we're going to create a soup object. BeautifulSoup is going to call in, it helps if I actually import BeautifulSoup. So from BS4 import BeautifulSoup, and then what we're going to say is soup is equal to, go back and do this correctly, BeautifulSoup, and we're going to pass in S, and we're going to specifically grab the s.content. So if I were to actually print off s.content, you would see, I'm just going to print off the first, let's say 500 characters of it, that it's actually a HTML file. The problem is that at this point, it's really just a string. What BeautifulSoup is able to do is it's able to take in that string and convert it into actual structured data. So if I were to print off soup, you would see a very, very long HTML file. And this is essentially all the data. Now, while this looks the exact same, this soup object is a special kind of BeautifulSoup class that actually is a very structured piece of data that retains all of this structure, all this metadata. And that means that we can parse it using Python. So let's say, for example, I want it to grab, let me just pick something at random. Let's stick with the TOC right here. We already have it pulled up. So I want to grab the div class or the div tag that has an attribute ID that's equal to TOC. I'm going to do this real quick and then kind of explain at a more basic level what's happening. I can say TOC is equal to soup.find div. I can specify class. Oh, I think the class is TOC as well, but just to be sure, I'm going to say div IOC, and then I can print off the TOC. And then let's go ahead and just do toc.text so you can see what I'm talking about. So this is what makes the soup object different. We're going to go through and explain how all this was done in just a few seconds, but what makes the soup object unique and particularly useful is that it retains all of the hierarchy of the HTML as a data structure in Python that we can then parse and analyze programmatically. So let's go ahead and try to learn how to do that right now. So I'm going to just zoom on down a little bit past the TOC. So let's say I want it to grab the very first div tag. Now, I'm not sure what that is actually off the top of my head, but what I can do is I can say first div, let's just create a temporary object, and I can say soup.find, and this is going to take one argument here. I can say that I want to find the first div tag and just print it off. It's this. It actually doesn't have any text whatsoever. Let's say I want to grab the first span. Maybe that's something that's useful. And it's got this R there. Not really all that useful. And oftentimes your first div tags aren't going to necessarily contain anything within them. So if I were to try to print off .txt or the text of it, I get nothing because there's no text between the div tag there. But notice up above that I was able to get all of this text from the ID of TOC. I can pass in a second argument here that'll be a dictionary. What this dictionary will be is a collection of keys and values that correspond to these attributes. So if I wanted to maybe grab the thing that has role equals navigation, there might be multiple things in this that actually do, but let's just see. I would specify the attribute first and its corresponding name. In this case, navigation. And I can print off that first div.txt, which will grab just the text, and I grab the exact same portion of the HTML file because it's the same, even though the ID up here is different, these same information is contained within different attributes. So I can specify very specifically which tag I want to grab. A lot of the time, however, the tags that you want to grab, there's going to be a lot of them. So for example, this is quite common with a p tag. So let's say if I wanted to grab the p tag. So I could say soup.find, and I could say grab the first, and this is just going to grab the first p tag. I can print off p tag.txt, and I've got nothing once again. So in this scenario, this isn't good. This means that I can't grab all the p tags. In order to do that, I would have to do something like this. P tags is equal to soup.find_all. And here I can specify p. Now, one of the things that you haven't learned yet is that you can tell the length of a list by using the len function. So I can print off len, or length, p tags. And I can see that there are 23 p tags found within this entire HTML file. With that bit of knowledge, I can iterate or move across all the p tags. So for p tag and p tags, print off p tag. And I can do that, and it goes through and it prints off all the HTML. Let's say I just wanted to grab the text of all the p tags. I can do ptag.txt, and it'll print off all of the text from all of the entire HTML file. So essentially, I can go through, iterate, and grab all the text from that entire page that is contained within a p tag. Now remember, p tags are oftentimes going to be, but not always, your paragraphs. So that's how I would grab all the different p tags. So this is very useful and very powerful for going through and grabbing a bunch of data off the web and actually parsing it. But what if I wanted to do more robust things? What if I wanted to grab a table maybe from an HTML file? That requires a little bit more work and a little bit of thinking about the structure of a table as it's represented in an HTML file. And that's going to be what we cover in just a few seconds. So in chapter 17 now, we're going to turn our attention now to tabular data as it's represented within an HTML file. And there's a couple tags that you need to be familiar with. You need to be familiar with table tags, TR tags, TH tags, and TD tags. We're going to go through each of these. So let's pop back over to our HTML file. Let's say I wanted to grab this very first table. So I could do inspect and inspect this. And if I scroll up, I'll notice that this whole table is underneath a table tag. And specifically, it has a class of Wikipedia table. So what I would do if I wanted to grab this table is I would do table is equal to soup.find, and I would pass in the table tag, specifically one that has a class equal to wiki table. And I can print off table. And we see that I have a long list of HTML. And what this corresponds to is that entire table. Now at this point, one of the things that I can do is I can kind of look at it and say, okay, well, this table has a bunch of TR tags. If I keep on going down the list, I'll see a new TR tag, a new TR tag. What TR stands for is table row. So if I wanted to grab all the rows in this table, this is why BeautifulSoup is so powerful, I can say rows is equal to not soup anymore, but table.find underscore all TR. So all of the different rows. This allows me to then say for row and rows, let's just print off the text. I can say print off row.text. And this allows me to go through and print off all of the rows. Essentially, I have retained all of that structured data. So this means that I can go through and print off also everything at this level, at the HTML level, and analyze each row. Now I'll notice that in the first row, which is going to be this portion right here, I have a bunch of what are called TH tags. TH stands for table header. This will typically be, if the HTML is structured appropriately, the first bit up here. This is how the table knows to render this section as different from the rest of the table. It's because that this is are the TH tags, so the row that has all of the TH or table header data. And so if I wanted to grab all the headers, one of the things that I could do is say maybe a condition. Or maybe I can just say headers is equal to row.find all TH. And then I can say for header and headers, print off header.txt. And I can print off all of that text. Now notice I got a problem here though. And we're going to go back to something we learned very early in this video about Python and working with text. We've got all this kind of white space between. I can do .strip and essentially clean up that text and look at all my headers. Now, so this allows me to actually go in and find all of the different headers and take it in and process it in Python as structured data, just as it's presented in the HTML file. This means that I can work with HTML and its structure programmatically through Python. But remember, not every row has header data. Sometimes that row will have something else. And let's go back and take a look. In other instances, we've got TD tags, which is going to be our table data. And this is going to be the individual, if we look up at the blue and above where I'm at right now, each TD tag is a new part of this cell. So each row is made up, and it's not the TH tags at the header, it's made up of a series of TD tags, each one being a new cell. And this is going to be consistently formatted because in order for HTML to be rendered correctly on a browser, it needs to be structured correctly in syntax. So you can typically rely on, unless the HTML is quite bad on a website, that this is going to be fairly consistently structured across most of their pages. So if I go through and I wanted to grab the TD tags, I could say cells is equal to row.findAll TD. I can say for cell and cells, print off cell.text. And I can go through and do all of that as well. So why is this useful? Well, if I know how to do this, then it means that I can take in that data from Wikipedia and actually store it systematically in Python. So one of the things that I can do is I can make an empty list. Let's just call this table rows equal to that. And I can say for each, or maybe just table data, I can actually append to that list whatever I want. So I can say table data.append cell.text, and I can go through and execute all that. And let me just print off table data underscore data. And I can print off all of this data now structured somewhat cleanly. If I do .strip, it'll actually go through and clean it up a little bit more. And what we're able to see is that all that table data, all those different kings' names, all their different coronation years, etc., is now in Python. And again, if I spent time, I could actually go through and structure this within Python. But let me show you something that might be a nice little trick that you can do. And I include this at the end of the textbook purely as a way for you to start thinking about problems as being able to be solved in multiple ways, all in Python. And again, one of the things I allow for you to do in this textbook is kind of go through and analyze outside of this video. Remember, I can't update this video, but I can update the textbook to explain things that might be a little confusing to viewers. But I can use pandas, and I can specifically use pandas read HTML. It will go in, automatically find tables for you, and structure them perfectly for you as a data frame. So I can do df3 is equal to pd.read HTML. I can do URL. And if I do df3 and print it off, it'll be a bunch of different lists of data frames. This is because it grabs all of the tables off of the page that I give it. But if I grab it at the index of 0, it'll grab the very first table that it finds and automatically put that into a data frame for me. Now, this is not always going to be perfectly formatted. Notice that we have portrait. It has NaN there, which means that it's NaN, which means that in this case, it's just a picture. There's no available data for it to actually parse that is text. But it's able to grab all that data and structure it perfectly for me in a Python pandas data frame. So my point here in presenting this is that not only do you have to use can use requests in BeautifulSoup to actually grab and parse a table, you can have other solutions for you that'll make it essentially, instead of maybe 15 lines of code to take it all in and restructure it as properly formatted data as I do in the textbook, you have another option that you can accomplish the same thing in just a couple lines of code. And this is the power of working with libraries. They're going to be a little bit more limiting, meaning you can't customize this right out of the box to do what you need it to do like you can with your own script, but it's going to work really well and pretty effectively pretty quickly. So this kind of wraps up this really primary introduction to Python. Again, the idea here wasn't to give you all the different things you need to know about Python to do all different things. That would be impossible, but it gives you enough of the basics to at least be familiar with some of the key terminology, the key ideas about data, how to create it, how to create data structures, how to do some more formal things like looping, conditionals, functions, classes, and libraries, and it hopefully gives you enough to at least start learning it. Remember, I did not cover everything in this video. I still find myself coming across things in Python that I don't know how to do, and I've been doing it for almost a decade now. But one of the things that you should be comfortable with is being okay with not knowing everything. If there's something that you don't know how to do, like I said, search on Stack Overflow. Or maybe you don't know how to do something. Google this question with the word Python in it. Like, how do I grab how do I merge two lists in Python? How do I merge two lists in Python? I'm just Googling this question. Of course, I know how to do it. Look, I've got some solutions right out of the gate. w3schools.com, a great website. How do I concatenate two lists in Python? Now you get to learn a new term. Concatenation is a fancy way of saying bring together. And this goes through. Somebody else is trying to figure out how to do it, and this is what they're expecting to actually have. And then wouldn't you know it, somebody down here has explained specifically how to do it. Again, this textbook in this video is not meant to give you everything, but it means to give you a good basis in moving forward. Hopefully now you feel at least confident in terminology to start exploring Python a bit more. And if you've gotten through this textbook to this point, you are good enough now to start working with other tutorials on this channel. Maybe dip your toes into, if you want to learn about natural language processing, go through my Spacey videos. I have about 80 of them, I think, at this point. Maybe not that many, but close to 50 at least on Spacey, which is one of the more powerful, if not the most powerful, natural language processing library that is available in Python. My point is if you practice the skills from this textbook, reinforce them over the coming weeks and months, you will be good enough to start doing other more advanced things and leveraging this basic knowledge to do more complex tasks in your own field or area of expertise. Because you're working with this data in this textbook, I encourage you to reinforce it with your own data. Maybe try opening up your own files. Experiment. The best way to learn about Python is to experiment. I cannot emphasize that enough. Hopefully you've gotten enough out of this, though, that you feel confident that you can kind of start going forward. If there's anything in this textbook or video that was not clear or you feel like could use some greater exposition, please do let me know in the comments, and I'll update the textbook to reflect that. Because like I said, I can update the textbook, but I can't update this video. If you've enjoyed it, please like and subscribe down below, and do keep on learning Python. You will be all the better for it, regardless of your field.